Good morning or afternoon or whatever. It's Michael. I'm back working on my game engine. Last time when I left off, I had just gotten to this stage in text rendering. We got the MSDF Atlas Gen library integrated with the engine. We got it to produce a texture atlas that looks like this, which is a multi-sign distance field. And we set up a simple shader that can take that and turn it into crisp, clean glyphs that are much crisper than the resolution of the texture that they came from. Since then I've conducted a bit of research or trial and error with some of the fonts and settings that I've got on my computer. And so I've learned a few things about how this library works, how this technique of rendering works, and its limitations. So for starters, things like this, where you got the little conjoined, the little blurry corner there, that's where you'd expect it to be a crisp line. That sort of stuff is just sort of endemic to using this technique to make characters with too low of a resolution. When you go to generate a atlas, you set in a series of either constraints or hard dimensions for what you want in your final texture. In this case, what you're looking at here came from the constraint that I wanted a power of two texture so that I could do bitmaps. And I set a minimum point size of the font to be 32, which is the default. All the MIPS are smoothly interpolating there when you zoom out, so it's nice and crisp, with the sole exception of the pixels in between the characters, which is fine because they're not even part of what you sample. But yeah, with those constraints, I came up with a 256 by 256 texture, which is not all that big. The equivalent point scale of the font is 37.34, which just comes out to the fact that that's as large as you can make all of these characters fit within the nearest power of 2 texture size. So when you're looking at the glyphs, it's more appropriate to compare them to the equivalent point size when you're writing text in another program. So in this case, the font size came out to be the equivalent of 37.34 font. So if we go to 38 font to round up, and we have A, B, C, C, D, comparing the apparent size of that on screen with the apparent size in the game is the proper point of reference for this. And you can see that it is quite close to being equivalent. In some cases, some fonts will not play nicely with lower resolutions. So taking a look at this A, even if we were to zoom out and make the letter A about the same apparent size as the A in Word, you can still see the little points sticking out there. So in a case like this, I would actually need to specify a higher resolution texture in order to avoid those kinds of glyph problems. So I think in my final implementation, I'm going to need to make a system in the editor that allows you to tweak the texture atlas generation settings when you go to import a font, because it's not simply that you can get away with lower resolutions on some fonts versus others. There's also the fact that the use cases may be different. You may not need a power of 2 texture in your implementation or your system that uses the text, because you might not need to have the text scale so small that it would need to do min mapping, and you might as well just save the space. The same thing is true for like 3D sampling. Like there's if we take a look at the shader that I'm using for this down in the data folder, where did I put it? It was like font renderer test. Yeah, here we go. This this method that we put in main, this method of figuring out the color of the pixel in the fragment shader and writing with it has a variable screen pixel range, which if you're not scaling the text in 3D space, then you may as well just make this a constant, so you can simplify what you're doing in your shader code. So there's a number of situations where the other settings that the library offers should be exposed to game developers in the engine. For the moment, though, I'm going to just get it working with the one mode, so that I can get text rendering working and start making an editor. And once I've gotten that far, to making an editor where we can start crafting data files, we'll revisit this so that I can implement like an import settings for fonts. So like when you go to bring the asset into the engine, you can have like an inspector view where you say, okay, I want to enforce these constraints, and then it'll produce the texture that you can use for your game, and it'll also allow us to do offline generation of these assets as well. So that it's not literally every time you start up the game taking some time to produce to calculate all the glyphs and produce the map. Or alternatively, it'll give you the option to cache it. I don't know. There's a whole bunch of extra features that you may want to add from this library into the game engine, and for now it's just a lower priority. So for starters, I'm going to head back to the dev state. I'm going to change the font that we're using to Roboto. I got a lot of commented code here from earlier tests. I should probably clean this up at some point, but this is just a kind of a playground area for me to try stuff out. So instead of going to see Windows fonts, I'm gonna pull Roboto regular from my game content directory, because I put a copy of the font there. I happen to like Roboto for a lot of things. I use Roboto for the enterprise logo text. Not the E, but not the stylized E, but like the words enterprise. And I just think it looks good, and it has an advantage as well that when I go to make the texture atlas, all the default settings make very clean text, with a couple of small exceptions, like that V doesn't quite get to the bottom there, and there's a little wavering on the W. W, for that matter, comes out a little weird, and I'm not really clear as to why that happens. You would think that this whole side here would be some other color, but for whatever reason, the library thought that this was the optimal way to do the coloring of the W. But if you're working at a reasonable size, like you're just printing text on a debug console or something, then it comes out to be quite crisp and clean with the default settings, and that's good enough for me. So after changing the font back to the one that I'm going to be using for the remainder of this video, I am going to do a quick tweak to my input. Test input.ini. Yep. So this is the input scheme that I use for running the game. I just have one that's got basic controls. I can press tab to toggle things. I'm going to tweak that real quick because I want to add an additional movement direction. So at present, I've got full first-person shooter controls where you got ASWD moves you this way, and whichever direction you happen to be looking at the camera. I also want to be able to interpolate up and down, pan up and down, given the nature of the stuff that we're looking at. So I'm just going to go ahead and add one. Might not be completely appropriate, but I'm going to name this new axis move Z. Just because move X and move Y kind of implies the main movement axis that like people expect to be able to move on a plane that's like forward and back instead of like through 3D space like this. So move Z here will be literally moving in the Z direct, or moving in the Y direction instead of the Z direction, and the Y moves in the Z direction instead of whatever. But I don't care for the moment. This is just for debugging purposes. Okay, and now I need to assign some letters. I think I'm going to do Q for down and E for up. And we reflect the direction by setting the scale here. So Q being down, you get -1, and E being up, you get 1. And then let's add some gamepad controls because I may want to use the gamepad to do like slower panning and camera manipulation while I'm working. So let's add a gamepad. I think what I'll do is I'll do the bumpers. So I think that's like L shoulder for the left shoulder. I sometimes forget what all the input schemes are, so let me hop back into here. Control IDs.h is where I keep the enum. So it's gamepad, D-pad, L shoulder, yeah, L shoulder and R shoulder. And so I'll do L shoulder is down and R shoulder is up. Good. And then let's wire that into the camera real quick. Okay, so here we've got the move X and move Y. We've got the movement vector is calculated from whatever camera direction we've got, whatever direction we've got the camera pointing. So basically we just need to get the orthogonal and move it up. So that would be cam pause plus equals I guess actually right vec is already calculated. So let me think for a second here because I don't do 3D math all the time. Input get axis move Y, so move Y pushing the forward direction. We would want to go move speed times move vector. Right vec is already the right vector of. Oh, that's funny. Why do I do that? I calculate the right vec here, and then I just for some reason like didn't slot it in to here. So that's how I derive the right vector. But for some reason I can't pre-calculate it and then don't use it. So that's weird. But I need the up vector now, so let's do glm vec3 up vec. And that's going to be the glm cross. I think I can just do the cross product of the forward vector and the right vector, unless I'm mistaken. Because you take, let me think about this. Because it gives you the vector that is orthogonal to the two vectors you put in. So you get the, right, I'm pretty sure. I'm sure this has probably come up a lot in the indie space. I'm just Googling the answer. He special upmaker as the tiebreaker when the cross product. What? Cross the right vector with the forward vector. Right, so right and then left, or right and then forward. I guess we'll see in a minute whether I got the ordering correct. But basically we just do right, and then move. The right back, then move back. And hopefully I got that order correct. Then we'll do input, get axis. In the input context we have bound, we'll use move z. And then multiply that times time game delta, so that way the camera is not shooting off at a variable speed. And then I need to do times move speed times up back. Okay. And let me see real quick whether that did what I wanted it to. Oh, we got a problem. What's going on? Get axis does not contain this axis. Did I mess up? Well, for starters, I don't see the file. So it's move z, sandbox content test input.ini. Really? We don't have, I must have put a typo in somewhere. So we got input, get context, move y, x, z, move z, axis mapping, control. Let's take a look at the console. Okay, I wasn't really expecting there to be a problem here. Let's go up the call stack real quick. Maybe I saved it in the wrong file. Input test context, yeah. Oh, right. I'm a buffoon. It's reading from the new copy first. So maybe that's an improvement I can add to the API. Basically what's happening is that the INI system works by making a working user copy from a known good copy. And I just edited the known good copy, and it's still loading from the previously cached user copy. So let's go into the data and just delete the data folder. Delete. Boom. And then we can stop debugging. And this time it should generate the thing from the other. Okay, so Q, I've got Q and E backwards. So E is supposed to go up and Q is supposed to go down. So that tells me is that I got the ordering wrong in the cross product. I should be doing where are you? Here you are. I should be doing move vec by right vec. It's getting the orthogonal between those two vectors, but it's going the wrong direction, so I need to flip the order. There we go. So now I've got a a slightly easier way to move around. Oh, but I'm just realizing now that I've also bound the right bumper on my gamepad to be the toggle, so I'll need to change that real quick. So toggle, instead of being gamepad right shoulder, let's do gamepad, I don't know, D-pad. Well, D-pad is already being used for movement. Let's do menu button, menu, save, and then get rid of the data folder. It might be a good idea for me to have like a command line option that forces the data folder to be cleared when you go to start debugging. I'm on the fence about that. There's a bunch of different directions I could take and change the usability. But anyway, coming back to the app. Did I save? Yeah. And we'll do the debugging again, make sure that the bumper working good, and now the menu button does the toggle on the other. So this will just make it a little bit easier for me to pan around and inspect things in the view. All right, putting that on back burner. The next thing to look at, I actually have to solve a little bit of a mystery. So I was doing some research yesterday after the stream and playing around with some things, and I think I had identified like exactly how to get the data that I need from each glyph to be able to draw them correctly. So there's a couple of methods. For starters, we have to do this per character. So for every glyph inside of the atlas, we have this glyph geometry object, and so we literally have to loop through them and get the data from those objects. Most of this seems to be working the way that you'd expect. So glyph.getAdvance gets you the number of pixels in pixel space forward to move the origin when you're about to draw your next character. So after you do print a character of glyph, the next character's or coordinates should be relative to the glyph's origin plus advance on the x-axis. That seems to be working correctly. Then you got a bunch of different ways to get to the bounds inside the atlas. My favorite of them would be this one. Basically gives you a left, right, bottom, and top boundary for where in the atlas to sample the character. And my early experiments showed that actually seems to work pretty well. And then get quad plane bound. This is a little more obtuse, but I happened to find a blurb by the person who made the library explaining this a little bit. That was underneath. Where's my projects? Oh, projects, enterprise. That was down here on some response to some issue on the library. He gave a clarification. Basically, it's like given an origin that's on the baseline where like the y coordinate upon which the letters rest. You use atlas bounds to sample from the atlas, and you use quad plane bounds to get the left, right, top, and bottom bounds relative to the origin for where you draw it. So it's a little confusing. It's not named particularly well in my opinion, but perfectly usable. And it appears to be that those values are working as well. What is not working very well, in my opinion, it's something that's unexpectedly difficult, is identifying which characters are which. So here I've got, when we go to load up the geometry, or after we've loaded all the geometry, we loop through all the glyphs, and I'm just printing the index and the code point. These are two different ways of identifying the characters inside of the font, the index being the order in which they were loaded into memory, and code point being the actual Unicode character that it represents. And you'll see what the problem is pretty much immediately. Once the thing's loaded, we take a look at what we've got in the console. There are two unexpected things. First of all, while we do have the 95 glyphs printing, the indices start at 32 and they stop at 126. And all of them have a 0 Unix or Unicode code point. So we can't tell which character they're supposed to line up to. Now, I was doing some testing. I wonder how easy it would be for me to quickly set that back up. I was doing some testing where I would pass a specific character's bounds in the atlas to the simple little renderer I've got going, so that I could display specific indices. And what I found was they don't even align with ASCII or any of the other. I couldn't identify a rhyme or reason for why it was picking the characters it did for those numbers. Like 32 in ASCII should be a space character, but in this library it winds up being an equal sign for some reason, and it seems to be consistent across fonts at least. But it blows my mind that it's not. That's not an ASCII order. And if it's not an ASCII order, how can I count on them being the correct characters? And why on earth can't I get the Unicode code point? Because I loaded them in specifically by being ASCII characters. When you go to load in the characters from the ASCII character set using the helper method provided by the library, it literally will just loop through all of the Unicode and insert and uses ASCII.add, and that adds them as Unicode into the character set. So it should be, when you do a add Unicode CP, you would think it should at least know what the code point is, but it doesn't seem to. Because this data is fed into the atlas generation, or the font geometry here, where it says load glyph set. Though you know what? Now that I'm thinking about it, I wonder if this could be a point of reference. So if we did auto car set equals this, and this would be of type, what would it be? MSDF atlas car set. And we just use the car set dot. You get the characters ASCII, which will return. It's a static method that'll return a character set full of the ASCII characters, which is how I set this up here. But now I'm wondering if I can get something from this set. This actually might be the key, now that I'm saying it out loud. This library has got some kind of really weird, obtuse things that I found, even after like doing heavy research to make sure I wasn't overlooking something. Like the glyphs, you have to use font geometry to handle loading the glyph set. So you load the glyph set into, wait a minute. Oh, is it just totally redundant? So there's a whole bunch of really weirdly redundant classes in here. So font geometry boils down to being a holder for for the glyphs. So it basically boils down to being a wrapper for this with some helper functions to get things started. But you can't access it directly, so like any of the methods that you need later on to generate your atlas, you basically need to have access to the glyphs anyway. So you have to make your own and pass it to this thing so that the font geometry will, yeah. But now that I'm looking at it, yeah, we do need it to be wrapped in font geometry. So when we go to load the characters, we need the glyphs contained within font geometry to be inside there, so that load glyph set will populate eVector with the glyph geometry. But then that's like its only role. Later on, we have to access the glyphs directly, and we can't go in and say font geometry dot get glyphs and just use that. You can't even use its helpful iterator to get it, because while you got your glyphs out of font geometry and you've got the pointer to the first one out of it, the pointer that it returns is const, and this needs to be a non-const, so you have to do frickin' a cast to MSDF atlas glyph geometry pointer. That's not a non-const. You have to cast it to a non-const, and I don't even know if that's even allowed. Is it allowed? I guess it's allowed, but it's like all this wordiness, and just because you can't directly use yeah. So you have to hold on to a reference for, or have to hold on to your own glyph geometry buffer to really use the API very well. Yeah, but let me get back to the previous experiment, because now that I've gone on the tangent, I think I might know the answer to my question. But let me at least pose the question. Setting this aside, and so we have the font geometry being loaded this way. Back down to the bottom, what I'm doing is I'm looping through the geometry to print off that same stuff, but now I am getting the quad atlas bounds for the character as well, and in the loop, I do a check to see whether the index is equal to some number, and then I send it out using an enterprise event as a tuple, so that way I can just use it somewhere else. And it's kind of just a cheap way for me to transmit data away from the system for the purposes of my testing. Hopping back into the init, I will now use it. So the first thing I do is I do a subscription to the event type that I broadcasted. I unpack it as the tuple of 4 doubles. I get them, I store them in LRPT, and now I've got them for use here. And what I use them for is I use them for setting the UV coordinates for the character, or for the sprite that we're going to draw. So what this means is that I will see only, instead of the whole atlas, I will see only the character at index 34, or 35, which in this case is the @ symbol. So @ symbol is at 35 for some reason. Equals is at 32. And there doesn't seem to be any rhyme or reason to it, but it does happen to be that when I go to plug in another font, I will get the same character out. So like if we do 100, I think that's the little C with the, I don't know what it's called, the Syracuse, or whatever the little apostrophe on the bottom of it, of the letter is. Or it's the sense symbol. Okay, that's interesting. But it's like these don't have any correlation to ASCII, because if you go to take a look at ASCII chart, the CPP reference 1 is nice. You look at decimal 100, that should be the letter D. And you should have all these other characters between 0 and 32 that are, spaces, admittedly, but 32 itself should be a space, and 33 should be the exclamation point. And yeah, it's just bonkers to me. So I guess the first thing to do is to figure out what the scheme is. My impression is that when you go to load geometry, the if you don't specify some option somewhere in the API that I haven't found yet, then it will only store the index for the font, or for the character, instead of storing the Unicode code point. This file here is from the console app that comes with the library that normally people will just run the console app, plug in their command line options, and use the program to generate the atlas given certain settings. So this is has been my point of reference for figuring out the library that has no documentation. This specific section is from the JSON exporter, which exports the character data from JSON. And it seems to be that these are kind of orthogonal. Glyph index and Unicode code point are like the two identifier types that you can use. You can actually even go into the font geometry and identify which one of these two it uses by using get preferred identifier type. There's also get identifier, where you plug in either glyph index or Unicode code point, and it'll spit out either the index or the Unicode code point. So when I go to generate from code, for some reason it is doing the index instead of the Unicode code point. And that's, yeah, I don't know what that's about. So now I think there may be an option where I can go through the charset class itself, and actually like compare the index against the code point. But it's just another thing to iterate through, and this is all with the sole exception of the fact that this is a multi-threaded operation. There's like nothing. There's in my opinion, it's like very like not intended to be very quick, because it does stupid things like there's like no way to create a character set that's not just inserting elements into an STD set one element at a time. So it might reallocate several times dynamically while you're inserting a character set of like, hundreds of characters potentially, which is not great. But if we go to, I suspect if we do a little bit more fishing, I might be able to find a way to create the character set in such a way that I get the character points out of it. So in this case, we are checking the glyph identifier type from the font geometry object. So that tells me that this is a property of the font geometry object, not the glyphs. Because remember, the font geometry object is the thing that handles loading the glyphs from the font. There's all these helper classes in between that sort of hard to deduce what they do, and hard it would take a while to explain what I've learned about them. But the gist is that you start up FreeType, you load up a font, which I suspect is just a wrapper for the FreeType font, and then you create a font geometry object, pass it in your own your glyph geometry memory store so that it's using your store instead of its own, and then you invoke load glyph set, which will actually take the font and the character set that you provided and load them up into font geometry. So maybe there's a method in font geometry dot. Maybe there's like a way to set the type. So you get set name. So you get the ability to say load set or load set name, load car set, or sorry, load load glyph set or load car set. Oh, okay. I think I just deduced something. So these two are basically equivalent, but one will load them as glyph indices and one will load them as Unicode code points. Oh, okay. I think this is it. In order to even assemble this code, I had to like cut it in from the console application, which has helped me quite a bit. But now that I'm looking at the alternative methods that were not used in the console app, or at least not in the branch that I was looking in, if we were to go to load car set instead, that might be enough. So the first thing it takes is the font. Next thing it takes is the font scale, which you're basically always going to want to pass one. My understanding is that like if you wanted to create a texture atlas that contains more than one font and you want one font's point size to be bigger than the other, then you can specify a non-unity scalar here to make it bigger or smaller than the other fonts. But I just leave it at one because I'm only doing one font. And then we need the character set, so that's actually going to be literally the same. We would pass in this guy. Oh, I hope it's this easy. That would make my day. And then pre-processed geometry and enable kerning. I want those both to be true by default. So that actually looks like it does literally the same thing. It's just a different method name, and it has the different side effect of returns the number of successfully loaded glyphs. It has the differing side effect that they are stored in memory as code points. So I think that might be what I need. All right, so now I've got this slightly different method of loading things. I suspect nothing will display in the window because we're not using indices anymore, but if we were to look in the console window, yes! Okay, I think that's it. I think that's what we need. Looking in the console window now, we've got still very confusing index numbers because it never starts with 0. And I don't know why it wouldn't, but it doesn't. But looking past that now, we've got a range that now starts with 32, which is the first character after all the control characters. So 32 should be a space. I'm not exactly clear on why there would be a glyph associated with that, but I guess let's find out. So down here, we are looping through all the glyphs. Now I'm going to say if glyph.get code point equals 32 to display it. So this will either be blank or like a underline or something. And it's blank. So let's go to 33, which I think is like an exclamation point, maybe? Maybe? We'll see. It is. It's all it's all super wide because of the fact that I'm not using the correct scale. But it is the exclamation point. Cool. Basically, I would need to actually set the size of the atlas to be, or the size of the quad to be corresponding to not the get quad atlas bounds, but glyph.get quad plane bounds in order for the scale to be correct. But I think we've got it. Now I've got a way to look up the characters by Unicode or ASCII association. Let's go for a couple of more tests because I'm not actually 100% confident with it because I was looking through the character map before, and I was having some trouble identifying the locations of some characters. So I guess in the ASCII chart, there's not any that we would be obviously missing. But let's find an unusual one. Yeah, let's do 95. Okay, yeah, it seems to be a dash. And then 42 should be a asterisk. And it is. 64 should be the @ sign. It is. And one more for the road. We'll do. Do the caret 94. Is delete literally supposed to print DEL when you do it? We'll do 94 and then we'll do 127. Good. Now remember that these are super blurry because because of how low resolution the texture is. The actual texture that this is sampled from is like a small portion of a 256 by 286 texture for the entire atlas. So even though it's amazingly blurry, we're still getting pretty crisp. Just got that little artifact there. That's okay. And then we'll do 127 because I'm actually curious now whether that actually uses the word DEL for delete. No, I guess not. It just represents delete. But for some reason it's all in caps. Maybe that's because it's like shorthand for, or like used as a macro somewhere. I don't know. But yeah, it seems like we got the character identification going, and that's actually the biggest leftover mystery for me. So now that we've got that, we should have everything we need to pick any letter out of the atlas based on the Unicode, value, and then assemble a string on the screen using the data that we can pull from the glyph. So now all that remains is designing a system that integrates well with the engine for drawing a string of text. I'm kind of on the fence about how to do that. I know that I want this to be part of the 2D renderer because I want both sprite rendering and text rendering to use the same batch rendering framework. So in a game scenario, having components that you can attach that will allow you to print text inside the game world would be one way that you could use it. But I also want the capability of being able to just invoke a method on the renderer class. Just invoking a method on the renderer class that says, draw me some text, please. And then it'll just draw it on whatever the current render target is. And for that matter, I do want to do a similar thing for sprites, so that if you're drawing like a UI, that you don't have to like design the UI in the level editor like you do in like Unity, for example. You don't have to do it this way, but a lot of times you'll open up the Unity editor and then make a scene that just contains your UI elements and then like load those on top of your game. I want to be able to do a straight call to the 2D renderer from a game state and just draw on top on the screen without making it like a scene file. So I guess the question comes down to what form do we want that to take. I'm going to go ahead and comment out this glyph picking stuff now that we've got glyph picking figured out. And then I'm going to take a look at the then we're going to take a look at the API I have for the graphics engine. Actually, I should take a look at the API I might use for the 2D renderer. That would make more sense. Render 2D.h. So when I was working on the original 2D renderer, it was actually just a very simple example of a batch renderer. It was not intended to be very robust yet. As I work through it, I think I'm going to make it a lot more robust. So the way that this will eventually work is that you can use this renderer if you want in your game, but you don't have to. So the way that you set up states and systems in your game is that nothing happens if you don't put anything in your game init function. So like you start off a blank game like this, really, and then for every system that you want, be it one that ships with the engine or one that you've designed yourself, you would set it up inside the init function. So here in my game init, I have I do a simple binding here because I just want no matter what systems or game states I have loaded, I just want the gamepad to be used for input if I touch it. So I have a simple thing that takes whenever the game detects that I've used a used an unused controller. So if I start using the gamepad for the first time, or if I start using the keyboard and mouse for the first time, it'll just automatically assign that to player one and start using that. And then after that, I just invoke the init call for renderer 2D. So it starts the system, which itself integrates into Scene Manager for so that you can have renderer 2D components and stuff and such in your scene. And then you've got State Manager push state, which actually just pushes the first gameplay state, which is actually where I'm doing all of my testing code, where I just throw stuff at the wall in this state. But eventually, a gameplay state would be something like a menu or a gameplay mode or something along those lines. So for renderer 2D, I think I'm going to make it pretty robust so that most people doing 2D games would use it, and most people using 3D games probably would also use it for if not for anything but rendering text. But then you can also just like make your own, and like if you're doing a pixel art game that involves like scaling and transformations and stuff, instead of doing like complicated shader hacks to do your anti-aliasing on your magnification filters, you might just do a renderer that automatically passes those values to your shaders, and you don't have to think about it anymore. But yeah, so taking a look at renderer 2D then, let's think of some ways that we can allow somebody to render text. So for starters, we could do static void raw text. We could have it take like a GLM vec3 for its origin, GLM vec3, or so we have to specify a point in space where it will draw from. But then you have like a number of other options as well. Like, do you want it to just like be the maximum size it can be filling a box, or do you want it to be like following a like word style, like going to the right from the origin, like left justify or right justify or center justify? Do you want it to do line breaks? And then like how big of a font do you want it to be? And what does that even mean in 3D space? These are some questions I don't really have the answer to for the moment, so I'm gonna have to just pick a direction to get started. I'm thinking Well, let's see how another engine does it. That might be a good point of reference. Does it have a text component? Text. Default graphic to draw font data to the screen. Okay, it does. That's in the script, so let's do Unity text. I just want to quickly see somebody's workflow doing this. And wait for the ad to finish. All right. I just basically want to see what the workflow looks like in an established engine, because even if I don't want to mimic the way that they do things, having a point of reference for workflows that have worked for people in the past might give me some ideas. So in this one, he's working Canvas, text component parameters. So text component parameters, we've got a position X, Y, Z, width and height, which is going to be in pixels. Anchors. Anchor is interesting because it suggests that you can place the anchor anywhere along the XY coordinates of the space. Okay, this is not helping me because I think this is just doing a text canvas component. Well, maybe that's what I need. Maybe I need to be thinking about this in terms of a component that has a width and a height like a sprite, and that you choose how the text fills that space. I suppose that would be one way to think of it. So if I was to do it that way, then I would need to have a position, a width, and a height. So actually I would need a position and an orientation. So I would need a GLM quaternion. That would be the orientation. I would need to have a width and a height, so we'll do GLM vec2, we'll do size, I guess. So using this API here, this API call, I'm just gonna focus on making that API work, and then later on, if I want, I can integrate it into my entity component system and actually make it like a component that you can place in the world. But for starters, we'll just do it through code. So we have the position in world space. You rotate your rotation in world space, and then the size, which I'm making a vec2 deliberately because what sense does it make to have a vec3? In the entity component system, size would be a vec3, but here we don't care about that. So once we have this, let me go ahead and create a definition inside the renderer. Once we have this, what does it mean to draw within the space? Maybe I should get a drawing tablet because that might help me work through problems on stream. But I'll just pull up Paint real quick. So let's say that we have defined the orientation in space. The orientation and position. And so we've got this like rectangle that we say, okay, this is the space in which we will write the text. We could have it just start typing from the upper right and break across the line when you get to the end. We could have it be like filling, like have it go as large as possible while still fitting within the space. That would be one way to do it. We could go a whole bunch of ways here, and I'm a little overwhelmed thinking about which way I want to take it. I'll tell you what, I'm going to go ahead and take a quick break. Been going for about an hour now. We did get one of the biggest questions that I had solved already, which is how do we even sample the correct character. Now that we've got that, I'm going to take a little bit to think about this problem and come back. I'll probably be about like 10 minutes or so, maybe 15. Maybe it'd be a longer break this time. Alrighty, I'm back. Had a little time to think, and even though I literally just downed a cup of coffee, I got some tea brewing because I need something to sip on. So I think I've kind of decided how I want to do this. And the thought came to me that because we're drawing each letter as a separate quad anyway, it doesn't make a lot of sense to me to confine the text to a specific quad. So what I think I'm going to do is I'm going to, for the moment, just do left justified text. But after we've got that working, add support for centered and right justified text, things like that. But the key takeaway is that instead of confining the text to a space and dealing with it like that, we will specifically work in in a space relative to the line height. So by that I mean when you draw a letter, the entire height of the line is defined by a value called EM, which is element height. So it's if you work in CSS, you might be familiar with EM size. Basically, EM size is a way of defining in a platform agnostic way how many pixels tall a line of text is, essentially. And it gets a little bit more. It's a little more. I say platform specific because it's a little more confusing than that. Because in that world, in the web dev world, a pixel is actually not literally a pixel on the screen. It can be, but it can also be another size depending on the device you're looking at. So, for example, if you're on like a Retina display on an iPhone or on an iMac, then a pixel thing that you perceive as a dot is actually much bigger than the single pixel on the display. So the pixel represents a size that's larger than a single pixel on your screen. But fonts work in terms of sizes like that. So we already have the EM size from the API. And so if you provide, working in the EM space, basically the scale that we're working on will define how big in world units, how tall in world coordinates the EM is. And then we will use that as a point of reference for calculating the rest. That may require a little bit of thinking, but basically you provide a point in space, you provide the EM height in world coordinates, you provide the orientation. Scale doesn't apply in the XY sense, it just applies in the EM size sense. And then from there, it will just print out text one character at a time along the baseline, with the origin being the point that you provide. I think that'll work best for the API itself. Hopping back into Enterprise here, because it'll kind of give you it'll give you a way to think about how the text will fit into the space, while still kind of giving you like a way to envision how the text will come out like a word processor. And we'll add different details to that later to make it work a little bit better. But first thing I'm going to do is I'm going to go and change the signature. Oh, come on, can't I do that from here? Do I have to go KO and right-click, refactor, and change signature? Okay. Okay, there's a symbol disambiguation, and neither of the symbols that it found are my draw text. It's trying to use the 132 draw text. Whatever, I'll just fix it myself. So we still need the origin and the orientation, but now we need a float representing the EM height, I guess. The EM height being the size in world space of a line of text. Oops. Yeah. like so. And then when we encounter a return character, we will change the origin up. So, yeah, here goes. I guess we'll just start coding and see what happens. So for starters, we'll need a transformation matrix. We'll need to be able to consistently apply the correct transformations to the quad. And the quad will be transformed relative to the baseline. Yeah, this is a little hard to think about. So for starters, let's hop back into Font Atlas, because I'm going to need to have some or all of this code. Let me close out of this. I will also need a way to get data out of the geometry, which I think I'm going to format in my own way. I'm not going to, for example, pass the MSDF Atlas glyph geometry array or vector to gain this information. Well, I might, actually. There's so many ways to go here, you know, and I'm just a freaking indecisive person, so picking a direction and sticking with it is kind of hard. I need a way for developers to be able to look up the glyph information of a character. And in on this side, we do that by calling glyph dot get code. Wait, no, that's not right. We would call glyphs dot get glyphs dot font geometry dot get glyph and provide it the Unix code point. And this will get us the glyph geometry. So let's say that we were looking for let's say we were looking for the exclamation point, which is 33. Then we can do dot get whatever. So I could, for example, hold on to the font geometry class and then pass all the data, or pass that to any system that wants it. So anytime somebody wants to write a renderer that does text, not that anybody really would want to reinvent this wheel more than once, they could just like get the font geometry and then call get glyph on whatever and get its data from that. I'm thinking that the way I want to do it instead, though, is that instead of keeping this entire font geometry thing in memory, I'm just going to store the important information in my own structure and then release the font geometry. Because the font geometry doesn't just contain the kerning and the Atlas lookup information and whatever. It contains the glyph geometry itself. So it actually will tell you. It'll actually give you the shapes in which you can generate another atlas. And for that matter, I think it actually stores the edge color as well. Let me double check. Yeah, it does. So like the edge coloring scheme, which is used for nothing but the generation of a MSDF atlas, it stores onto that all that too. And I'm not going to want to hold on to all that information. So let's come up with a way to store it. I'm actually going to bite the bullet and just do this right now. I'm going to move the texture loading method, or the atlas loading method, directly into textures.cpp, which is where I do all my other texture stuff. Which will allow me to get rid of a handful of extern references and consolidate this with the other texture loading code. So I'll need SDF reference count, texture handles. Do I use these? I do. Okay. So let me cut all of this. By cut, I mean copy and comment out all of this. Comment out all of you as well. Well, for the moment, comment you out, and then I'll come back to you. Go into textures.cpp, find a good spot for it. So we've got all these load texture methods, which a lot of them are just waiting for me to implement them because I don't have a use for a 3D texture right now. I just know that the API will call for one eventually. And then I can do the load font file method. So graphics, texture handle, graphics, load font file, and accepts that. And these I'll put at the top. Up here for the moment. And now that I've made this change, back to fontAtlas.cpp, I'll need these as well. For the moment, these are the default values that are not actually part of the MSDF Atlas Gen API, but the console application uses to set the defaults. So I've just copied them in from the console app to use in my algorithm, so that they're clearly marked as things that can be tweaked. Which I won't bother until I've got an editor made. And then back into here, texture reference count, sampler, type needed for texture, texture handles by path. These guys no longer have to be externally linkable. I do need to have, do I need to have isnsctf? I actually didn't wind up using this for anything, interestingly enough. So I do need to get the Atlas Gen header in this library. Here we go, and I'm not using events in the other side either. And font atlas.h. I'm not even using this anymore. So I can actually get rid of these files, and I'll do that in a minute. Good. So first let's make sure that I get this to compile. There we go. And once I've done that, I'll just remove those two files for Font Atlas. I don't even think I need that to be its own thing. I just need to make it part of the texture system so that I can get the texture information and the UV information from the same place. All right, press F5, make sure I didn't break anything. I'm going to be mighty pleased with myself when this is done. But okay, we're back. We've got the thing working. It looks like we didn't break anything. So now that I've done that, let's go back to fontAtlas.cpp. Do a once over, make sure there's nothing left I need. Nope, we're good. And fontAtlas.h. Nope, we're good. So I'm going to go ahead and close those and just straight up delete them, because I don't need them, because they're trash and they should feel bad. All right, there they go. And now back to this class. or this structure. Now that I've done my consolidation into this file, I no longer need some of these to be externally linkable. I had to, because I thought I was going to do this as its own thing, separate from textures. I thought that I would need, yeah. I thought that I would need to do external linking to prevent OpenGL code from finding its way into my headers, but that's not how it seems to be anymore. I know that I need at least one of these to be externally linkable. I just don't really remember where. So these two things are defined in shaders.cpp with external linking because sampler uniform types and locations, those are things that are defined by shader compilation, so it makes sense to define them there and just have them referenced in here. But current sampler assignment and sampler type needed for texture, this is specific to binding textures to texture slots, so those need to be local. Good. I'm going to press F5. I suspect that one of these things is going to break because I think I have an extern from here. Oh no, I don't. I guess not. Okay, so I can just leave it all as statically linked. So this is all within one translation unit. Current slot of texture is not, but that's because it's part of the graphics class itself. It's a static in the graphics class, and it's platform, or it's graphics API agnostic. So it's something that stays in the enterprise API. And good. Now that I've got that kind of reorganized, I need to come up with a way to store and look up texture information or character information. So thinking this through as to how we're going to use it, we need to start by getting the UV information per character, the offset information per character, that is where you place it relative to the origin of the character that you're drawing. You need to know the advance of the character, so each character you need to know how far to move the origin for drawing the next quad. And you need to know character-to-character kerning information. So kerning is a little bit of a strange concept, and from what I understand, I've never done this before, so I'm learning a lot of things for the first time. But my understanding is that kerning is like when certain characters in the font are designed on a case-by-case basis to be closer or farther apart from each other, just because those two characters are designed to go closer or farther apart from each other. And so it's literally arbitrary, but it's part of what the font designer intends. So it's something that you have to consider, so that like first you draw the character, then you advance by the advance amount, and then you will draw the next character using that character's normal offset, and then offset it again by character kerning if there's a kerning value between the current character and the last one. So the thing that's in common with all of this data is that we get it per character as we write each character. So we're going to need to have a method for looking up each data point going forward. So I'm not usually one for writing structs to pass data around. I think this is a case where I'll make an exception. I usually like to pass around data using something like like an STD tuple if I had to send more than one data point, like using a standard container for data that you can just like take a look at the signature and say, oh, okay, this is a tuple that contains this, this, and this. But in this case, there's enough data to be passed around, enough of which has similar data types, that I think it would make sense that I would bundle it up into a structure that you can just access the data by name. So let's head down to load font file. So load font file currently takes the path of the font. That's it. I need to do another static method. In this case, we'll need to return some kind of thing, and I'll come up with that thing in a minute. And it'll be get font metric, I guess. Metric as in the singular of metrics, metrics being the overall font's spacing information. So I don't know if this is grammatically accurate, but I'm going to use it for the moment. Get font metric. Then we need to provide the character that we're looking at. I'm a little on the fence about how I want to do this because I don't know what my limitations are. When you use get glyph in the Atlas Gen API, you're using a type def that they specify called Unicode T. It boils down to just a uint32T, which should be enough to cover the entire space of Unicode, I believe, because Unicode covers only 32 bits in the UTF-32, which is all that TTF files can encode, I think. Can TTF files contain viruses? That's a funny suggestion from Google. Can TTF files contain UTF-128? Because there's a number of different levels of UTF. UTF-8 covers like all the basic English stuff. UTF-16 covers a lot more. UTF-32 covers a lot more than that. The library that we're using for the texture atlases only goes up to 32 bits. And believe it or not, I'm wondering whether that's enough, because eventually we're going to need to add language support for other regions. And, like Chinese has like thousands of characters, for example. Maybe I can get a little bit of clarification here. Background application of Unicode fonts, glyphs, current pairs. Okay, this is a lot of data for comparison of fonts. I just kind of want to know whether UTF. Oh, really? It doesn't even occur on this page. Interesting. Let me just put it as a straight question. Do I need to support UTF-64? Or 128? Is there not a thing such as, I thought there was, wasn't there? UTF-128? Did I dream that? I could have sworn that there was more. You know, 32-bit depth gives you a huge number of characters already, but I could have sworn that there was more. Whatever. For our purposes, we're just going to do a uint32T. I had a conversation yesterday with a streamer about, or just yesterday or the day before, I forget, about type defs and their utility, and I don't think this is necessarily valuable. In this case, it's especially not valuable because you got 1, 2, 3, 4, 5, 6, 7, 8, 9, and 1, 2, 3, 4, 5, 6, 7, 8, 9. Literally adding a character to the length of the thing that you're typing. I mean, I suppose you could make the point in this case that it makes the purpose of the type a little more clear. And I do a couple of type defs in my own engine for the purposes of making concepts clearer for like When I'm using an ID, for example, almost all ID types are unsigned integers. But I might give it a specific name, so that way when you're looking at the signature, you'll say, okay, I'm looking for the texture handle, or the I'm looking for a hash name, even though that's just the unsigned int as well. So you can make a case that Unicode T would make some sense, but I think I'm going to use uint32t in my case because I'm not using Unicode everywhere. This is going to be something that only people who are using who are designing a text renderer might use. So that person probably understands that when I say uint32t char, then you're talking about a Unicode character. So we'll do uint32t Unicode character, and then we need to define the structure that it returns. I will keep it within the graphics system, I think. Do I want it in the graphics system? If I leave it within as a subclass of graphics, then they would have to type graphics : metric or something. No, I think I'll take it outside of the space. So that way, if you're rendering or if you're making a renderer in your own game code, you don't have to bother with the extra typing. So let's do a struct. We'll call this character metric, or car metrics, I guess would make sense. Yeah, what will we need? We'll need to have a GLM vec2 for the UV on each opposite corner. We're always doing axis aligned rectangles when we are sampling from the atlas, so it'll just be GLM vec2 for the lower left and upper right. So it'd be atlas UV lower left, and then atlas UV upper right. I don't know if that might be I don't know. I'll work on the names later. So we got the sample points from the texture. I suppose you would need the texture itself, should you? When you're looking up the metrics, you're going to need to tell what font you're using. Which tells me we're going to need to expose in the API a way to track a loaded font. That's maybe a bit complicated. I'm not so clear on that. Taking a look back at the textures.cpp file, we basically have two ways of tracking this anyway. We've got MSDF texture handles, and we've got MSDF reference count, specifically for the sake of tracking whether we've already loaded a texture or loaded a text atlas, and how many times it's been bound as a texture. Or how many times it's been loaded as a font. For reference counting. I suppose what we could do is we could accept a texture handle So when you go to load a font, you get a texture handle, and you can use it in anywhere that you would bind a texture for use in the shader. We can use that as the handle to the font. That makes sense to me. So down here, I'll do, as the first parameter, we'll do texture handle Atlas, and then UN32T Unicode character. We've already got a name going for parametrics, so I'll throw that down here as well, so that's not giving us any problems anymore. That'll be a return by data, or return by copy return. Return by whatever the opposite of return by reference is. Return by data or something. And then we'll need the coordinates for placing the character relative to the previous character. So there's two ways that I could do this. I could just do these as separate data points. I could do vec2 for quad chords for lower left, and then quad chords for upper right, and then maintain this separately from the kerning. But another thing I could do is I could do a lookup that, like a lookup method that accepts the previous character as a parameter, and then will automatically do the kerning lookup for you and return the coordinates for where to place the quad relative to the new origin with kerning applied. I think I'd like that idea more. Let me take a quick look at, I've got this little WebGL guide for handling things like kerning as a reference as I go. If I've got, and this uses a different library for getting the offsets and things, so that data presents a little bit differently. But let's talk about kerning. Kerning is taken into account in the offset of blah blah blah. Kerning, horizontal kernings. The thing that I'm confused about is whether kerning is ordered. And I guess that's not a question of how kerning works in principle, but a question of how the MSDF Atlas Gen API works. So I'm gonna do a quick little test, I suppose. I'm gonna comment out this guy, and I'm gonna leave the struct as it is, just so that we have something to compile. And then I'm gonna go back into textures.cpp, go into the Atlas generation code, and I will do a quick little test. Am I still rendering the characters? I noticed I didn't comment out this section. Or am I rendering the whole atlas? I suppose I just did a fairly substantial restructuring, so it'll take a second longer to load or to compile. But still, please hurry up. Oh, there was I did have a problem. Oh. Now the Atlas stuff is part of graphics.h, so it's automatically included everywhere that I do rendering stuff. All right, cool. Yeah, I guess we're not doing that anymore. So heading back to the renderer, or heading back to the font Atlas generation, I'm going to print out some data. So first we're going to go through every glyph. This is outputting currently the code point. What I'm going to do is I'm going to do the code point, and then I'm going to print out the kerning value. So glyph dot get metric, or get, or is this underneath font geometry dot get kerning? Yeah. So the way that get kerning works is that we get a map associating a pair of glyph indices to advanced values. Which is a pair of two ints are technically different if the ints are reversed, I think. They're not identical if one comes before the other. So what I'm curious about is whether it matters the order. If it doesn't matter the order, then the API can work just the way I imagined. Otherwise, we'll have to think about what those values, what the ordering means. But the thing that's giving me pause right now is that it is requiring you to provide the glyph indices, not the code points. So to review, I suppose I still am getting indices, if I think about it. Let me check the output here. Yeah, so there are still indices coming out when I go to get glyph index. For whatever bonkers reason, the index doesn't start at 0. I don't know why. Maybe there's some kind of like internal representation thing where like they use like the first 3 spots for scratch space or something. That's the only thing I can think of. But I know I can't just start iterating the glyph number from 0, or the glyph index from 0. But what I can do is I can do font geometry dot get kerning, and then get the map, which is going to be, let's do auto for this for the moment. Kerning equals font geometry dot kerning, and then I can do kerning at an STD pair, which actually, because this is a map, I would have to actually do the bounds checking. So kerning dot count, and then look up the pair. So STD pair of 2 indexes. Oh my god. So what we'll do is, while we're iterating through all the glyphs to print out data about them, I will no longer get the Atlas bounds. Actually, I don't need to check for character 32, 38 anymore. I will just say glyph code point, and I will print out the kerning for I'm actually going to do something maybe a little wild, and I'm just going to print out the whole container. So EP trace kerning. I have I have Pretty Print installed in this game engine. Pretty Print allows you to simply print out the entire contents of a container. So I know it's going to be a little bit messy. Yeah, there's a lot of values here when I go to print out the container. So this isn't adding any keys through a reference or anything like that. Let's see if I can get a spot where it starts over. Kerning, core kerning. So we got things like 5.5, and then we got negative 0.0522461. What I want to do is I want to see if the pair can come in a different order. So we got 510. Do we have 10.5? This is going to be a little bit hard to read. So what I think I'm going to do is I'm actually just going to. This is maybe a lot for simple debugging, but I think I'm actually going to just write the contents of this kerning out to file. So what I'll do is I'll do file text writer, give it a path, so I'll do into the data folder, and I'll call it kerning stats, the kerning roboto.txt. And then we'll do, I need to give it a name, writer, and then writer, I'll just output kerning. I suppose I can just do kerning, like so. Because it takes the OStream operator, and yeah, and then I can do writer.close. I really dig my file writer API because it's just so easy to use. And it automatically uses my file system, and it automatically does the safe file writing by writing to the temp folder and copying over. Yeah, I'm really happy with myself. Yeah, so I'll go ahead and run it again. This time, instead of printing to the screen and trying to read it from the console, I can open it up in a text editor and get a little bit more information. So we'll go to the data folder, go to data, and now we've got kerning roboto, which is this is a lot of data, but not nearly as bad to read here. So what I'm looking for is to see if there's any reversed pairs that comes out of this API. So for starters, 510 is associated with the kerning negative 0.522461. What I'm curious about is if 10.5 is the same. Cannot find 10.5. That's interesting. So I'm going to assume it's the same for the rest of these. So there's a 536 up here. 36.5 doesn't exist either. That's interesting. So the fact that this is a pair that has only one entry per pair, but it's always ordered. No, it's not always ordered, because now down here we've got 8010. It's a little weird that it says can't find 8010. Oh, you know what? I'm being a dingus. Let me open this up in a reasonable text editor, yeah. Because what it was doing is it was doing the old school way of looking past the cursor position and nowhere else in the file. That's not helpful. All right, so we got 510 exists only once. 10.5 also exists, and it is also negative 0.0522461. Okay, so there is plenty of duplication in here. So if we do 36.5, It also exists. Oh, but interestingly, it is a different value. Okay. All right. So the in the case of 536, I guess the order of the kerning matters. That's the important detail that I wanted to learn that I didn't already know the answer to because I've never done this before. So it appears that if you have 5 followed by 36, that's the way I'm reading this, then you need to have have the character, the 36 indexed glyph needs to be offset to the left by 0.05175778 units. Not a lot, but subtle enough to matter to make the text look correct. But if you have a 36 followed by a 5, the glyph at index 5 needs to be shifted by a smaller value, by 0.038572. So the order here does matter. I am presuming that this is in left to right order, so this is referring to the kerning of character 36 following the character 5, but I don't actually know that for sure. I'm just going to operate under that assumption because the API doesn't document this stuff for you. I'm going to operate under that assumption, and if the text looks wrong, I'll try it the other way. But this does tell me what I need to know to move on. Let's head back to the code I just wrote. I don't need to print the kerning anymore. And so we get the kerning from the geometry. We'll need to package it into a similar format. And actually, the format is not. I think I'm actually okay with this format. The map with the pair being the key, and the double being the other. The only thing that I would need to change about it is I need it to be, instead of indexed, I need it to be Unicode code points. So font geometry dot kerning. That's it's a little weird that you don't have something to get the kerning based on whether you want it to be code points or not. You think that it would be a common association that you would need to look up the kerning by the Unicode character to the Unicode character, because that's the data that you're working with when you decide what glyph you're going to use. And it's a map, so it's all associative anyway, so I don't know. Like the actual practical application of MSDFs to do glyphs this way, I think that's just like crazy mad genius and cool that it works. But I'm getting a little frustrated by how obtuse the library is written, and in some cases just naked inefficiencies that I don't understand why you would ever want to do it that way. But putting aside my personal grievances, let me just get this figured out and then use it. Returns the type of identifier that was, metrics, get metrics. Returns the processed font metrics. Returns the complete mapping of kerning pairs by glyph indices and the respective advanced values. Wait. Maybe this is a property of the metrics. No, the metrics is just global stuff. So you got the ascender Y, descender Y, EM size being the size in pixel space of one line, which we're going to use as our scaling factor when we go to write out characters, by the way. Line height, line height is actually different than EM size. So EM size is the unit, and line height can be, you can have consecutive baselines be, you can have the lines spread farther apart without changing the size of the line. Like if you think about like in like grade school, how you would have the lined paper, where your teacher might have you do every other line so that they could write in between your lines. Yeah, so even though I like the format of an STD map to the kerning value, I actually have to iterate through this anyway because I need to convert the indices into code points. So great. All right. So in here, let's head back to the struct that I was writing. I'm going to make a private section for holding the quad coordinates for the lower left and upper right, because we're going to do a method to get quad coordinates that have applied kerning from the previous character. So we'll do glm vec 2. I suppose what I'll do is I'll do a glm for I can either do a glm vec 4 and have the first two be the lower left and the right two be the upper right. Or I could do a pair of vec2s. I think for clarity, I'm going to do std pair of glm vec2s. Just to solve a point that just looking at the API, you realize that these are intended to be used as two separate points. And we'll do I guess quad chords. And then we'll accept the uint 32t prev unicode car. So this getter will too few arguments. Oh, I gotta say glm vec, yeah, vec2 again. So this getter will basically take this and apply the kerning value associated with the previous char and the current one. So you don't have to think about kerning when you get the coordinates for the character. I think I like that quite a bit. I'm going to just make this inline. You just do the math right here in the header. But in order to do that, I need to have the structure containing the kernings. So what we'll need then is I'll need to make this a private member of graphics, because I don't want it to be accessible directly by the dev. Well, I suppose we could make it directly accessible by the dev. There's no harm in that. But they would just be doing themselves a disservice by having to do the math and look up themselves. But what we need is a basically a std map of std pair uint 32t as the key, and then as the return value we get the std pair of quad coordinates. And this would be What am I doing? That's wrong. What I actually need is to associate the font. So we'll do graphics texture handle. So we're associating the font with the double, which is the kerning. Wait. Oh, it's going to be a little bit more complicated than that. We're going to need to associate it with an STD map containing the STD. Okay, yeah, this is going to be a little messy. STD map where you have the two characters, the two Unicode characters. So uint 32t, uint 32t, and associate those two pairs with a double, which will get you kernings, I guess. Expected a, oh, I forgot a closing angle brace for kernings. So this would be what we actually look up the kernings with. We would get the float value for the X position offset, and we would apply it to the left bound when we return quad chords. I don't think I want this in the global namespace. I think I want these to be stored underneath graphics. But at the same time, if I was to put this underneath graphics, then character metrics, the struct, wouldn't be able to see them by default. So I'd have to make it like a friend of the graphics class, which, I mean, I guess there's no harm in that. Let's do it that way. I want to hide anything that's not, that's like too much information or not easy to use from the developer. So in that spirit, I would put the font kernings as a member, as a static member of the graphics class. I would make the car metrics a friend of the graphics class, so that way graphics can access the private members of graphics. And then from here I would access graphics font kernings, and I can get the kerning for the I'm just now realizing that for me to access the kernings, I actually do need to know the texture handle of the font that we are getting it from. Which to me is telling me that this API is too obtuse. um, it would be better to just have a method that gets me the kernings directly for use in the renderer, rather than returning this struct that contains this data in this helper. Yeah, I've changed my mind. I'm not going to do it this way. So now, going back underneath the texture stuff, we still do need a way to look up the kernings. So this font kernings static member should still exist in graphics, I think, because then you can provide the texture handle that represents the font, or the font atlas, and then look up the kerning between any pair of two Unicode characters. But what's different is that I think I want people to be able to directly access this. So what I'll do is I'll take it out of the private section. And just make it const. Can I do that? I don't actually, now that I'm thinking about it, I don't think that's how it works. I think that I would need to keep it non-const inside of the class, because I'm going to be modifying it after initialization. I just won't be able to modify it outside of, yeah, so I'm gonna need to get a getter. One thing I don't like about C++ that other languages like C# have is that you, in order to keep members selectively read-only, you have to do getters and setters. So you can't just make a read-only property inside of a C++ class. You have to actually make it a private member and then use a method for getting and setting, which is dumb. Or a member for getting, I should say. So yeah, with this being here, let me go ahead and go into textures.cpp and actually define it. I'll leave that down here. Oops. Static. I should grab the whole thing. All that stuff. And this will be graphics font kernings. So now it'll actually link to the one defined in this translation unit. And then I'll need to go back to the API where we got the load font file. And then instead of doing just get character metrics, I'll do two different methods. This one will be for SD pair of glm vec2, glm vec2, 2, I said. And this will be get font UVs, or get font car UVs. Might be a little wordy, but atlas, Unicode character, yeah, that's pretty good. And then I need to do another one for getting the get font car quad chords. I guess that makes sense. So what this method will do is it will return the quad coordinates of relative to the position, to the current origin as we've advanced through the string, give you the actual lower left and upper right positions to place your quad into world space, or into model space. Model space being the space for the entire string, as opposed to space for just the one character. And and what I can do is for quad chords, I can optionally ask for the previous character. uint 32t. Because what you can do with the previous character then is you can specify when you're looking up the quad coordinates what character came before this one, and it'll automatically bake in the kerning into the quad chords. I like this actually quite a lot better. I was overcomplicating it with the returning a struct containing all the data. Sometimes it's appropriate to return a struct full of the data you need that has named members, but actually I think in this case this is a lot easier to understand for somebody writing a renderer. Cool. So I feel like I'm forgetting something pretty big, but I don't know. Figure it out later. So let's go ahead and implement these. Given the tight relationship that this has to textures, I'm going to go ahead and put these methods in textures.cpp as well. We'll just make this a part of the library. Like so. Part of the graphics library. And now we can get the sampling done here. And because we have the kerning, font kernings defined up here, we can just start packing that data in from the load font method. But now that everything is all in this translation unit, I can actually go one step further and remove font kernings from the graphics class. That'll make things that much simpler. Because now I can just directly pack it into the static font kernings in the CPP file and directly access it in the same CPP file. So cool. Might be getting a little bit crowded with the methods in this textures file, but I think I'm okay with it because we're only at like 500 lines right now. And everything in this file is textures, so it's not like you're not expecting the Atlas stuff to be in here. Cool. So let's go ahead and start packing the kernings. So fontgeometry.getKerning gets you the kerning map to look stuff up with. Let's go ahead and make that the std map for std pair of. I'll go ahead and use the same type as the. No, I'll use uint32t instead of specifying the namespace. And then associated that with a double. Right? Okay. Right? No. It gets you get kerning returns map pair of two ints and a double. Right? Because these are indexes, not code points quite yet. And then I actually need to move that up a bit because this is for every glyph in glyphs, and I will just reference it while we're iterating through the glyphs. So font kernings, we will need to in place at the pair representing the glyphs the double. So this might be a little difficult because we're going to need to this structure is designed where the key contains the left and the right side of the kerning pair of and I need to actually what I need to do is I need to, instead of looping through the glyph geometry, I need to loop through the kerning and then do a direct conversion for every left and right side to glyphs. Is there an easy way for me to do that? So we have get glyph, which accepts the code point, but in order for me to get the index, in order for me to go from an index to the code point, I actually need to loop through glyphs and find it. And I can't just directly access the element in glyphs because the index is not a one-to-one correspondence to the index in the underlying array of glyph geometry objects. So it kind of looks like I'm going to have to first loop through all of the glyphs and then store all of the associations between the index and the code point, because this is the only way I can think of that I found in this API for getting the association between an index and a code point, and then use those to convert all of the keys from font geometry.getKerning when looping again through all of the font geometry or all the kerning values in getKerning. All because I don't have a way to get kerning from Unicode code points, which blows my mind a little bit, because you would think that the number one way that you would want to get kerning would be to say, I have this Unicode character and this Unicode character, what's the kerning between them? But no, you have to do it by index. So and you don't have an easy way to look up the index. So that's freaking great. But I guess that's how we have to do it. In a shipping game, this would all be done offline anyway, so that you're not having to build all your texture atlases at first launch, or maybe you would just do it. You would cache it at first launch, and so you wouldn't have to do this every time you launch the game. But either way, I'm not exactly happy with the way that this API is arranged, even if I'm happy with the text rendering as the product. So at some point I might actually, like, if I have like a if I have a night that I just can't sleep, I might just go and do some changing of the API directly, because I have a fork of this library going. But for now, what we'll do is we'll do for auto by reference. And we'll use STD structured bindings here. We're going to need to get the key and then the value. So what we'll do is we'll do index or indices key for the STD pair, and then we'll do kern val for the double. And we'll do this for every kerning in font geometry.getKerning. And then we'll just delete this. So this will be where we actually go through and convert the indices into Unicode code points and then stick them in our table. This loop actually has to follow this loop, now that I'm thinking about it, because this is the loop in which we will get the code points and associate them with the indices, which is crazy that I have to go through 2 loops of all the glyphs just to get this information, but whatever. So in order to do this, we'll need to have, I'll just do an STD map associating the index with the Unicode code point. So it'll be int with uint32t, code point. It'll say index to code point. And then as we're going through this, we'll say index to code point at glyph.getIndex equals glyph.getCodePoint. Okay. So this will allow us to, in this loop, say font kernings, which is our storage for the font kernings. Font kernings at index to code point. Oh shoot, that's going to be, let me do an std pair here. Pair of uint32t, uint32t, and we'll do this as, instead of indices key, this will be code point key, code points key. And we'll set that equal to we'll use that constructor on it. We'll set that to indices key, right? Index to code point, and will be indices key dot first, and then index to code point indices key dot second. We'll see if that's less wordy in the long run. But basically we're making a pair that is now uint32t, uint32t, where we're using the associated code point to make a key that is the Unicode to Unicode code point. So when we go to look up the kerning value, when we go to render, we don't have to know the index of a glyph within the font. We just need to know what the Unicode character is. Seems like a whole lot of work to get this to work. I really hope that there's some part of the API that I'm just not aware of and unable to find that does this all for me, because otherwise this would be just a grave oversight on the library. But whatever, well, I'll just deal with it. Whatever. Font kernings. So now in font kernings, we can store at code points key. We can store the value in the kern val. So kern val is the float associated with the index key. And so we just do a one-to-one correlation there, I'm pretty sure. No operator mentions these operands. Did I mess up the type of this guy? Oh, right. So font kernings is actually a multi-dimensional map. We've got a map associating the texture handle with the map associating the data point. So actually I do need to put something in here, and that something is going to be the texture handle. So that's going to be texture handles by path, return val, because return val is the texture handle that will be returning. So we'll use return val. Cool. And then we have the font kernings now. We finally have a way to look up the kernings between two Unicode characters. And we can use that here in getFont quad coordinates to calculate the distance, or to calculate the new coordinates with respect to the previous character. Cool. And I'm realizing now that I actually do need to add an additional getter. I need a way to look up the advance of each character, because the kerning is relative to the advance. So the advance, the advance is how many pixels forward you move the origin for the next character that you draw, and then the kerning is relative to that. So it'll be static std, double, I guess. I don't know if I care enough to use doubles. I'll use float. No, I'll use double, because why not? Static double get font char advance. This will take the name of the handle of the atlas to identify the font, and it'll take the Unicode character to get you the value. And this one might as well be inline. The only thing there would be that if it was inline, then I'd have to link the data store for it from this header, and I don't think I want to do that, so I'm just going to go ahead and get getFont advance. I'll just do it directly. Cool. And then yeah, okay. So I think we've got a solid game plan now. We have a way to get the data. I'm going to want to take a break here in a minute, but before I do that, there's one piece of data left that we haven't gathered so far. And that is when we are getting the kernings, we also need to get the advance. So for every glyph that we get, we need to, or every glyph in the font, we need to store its advance. So heading back up to the static variables we got up here, I'm going to do another std map associating the texture atlas, texture handle, with a map associating the character with the advance. Uint 32t with the double. Font advances. And then we will store in the first loop here, font advances at return val, being the handle of the texture that we're associating with the atlas. Font advances at return val, and then we're associating the character, so glyph.get code point, with the advance. So that would be glyph.getAdvance. Bam. Okay. So now we've got all the data we need to generate the UVs, the quad coordinates, and in this case we'll just return font advances, atlas Unicode car. Oops, Unicode car. First doing a bounds check. If font advances, dot count atlas is greater than 0. Oops. And then, whoops, and then if font advances dot count, or if font advances at atlas dot count Unicode char greater than 0, then we will return font advances, whatever. Else we will generate a warning. Oops. I am having a weird time typing right now. Graphics get font car advance, and we'll say is there an easy way to convert a Unicode character to a character? The output stream is UTF-8. Whatever. I'll just do it as a number for now. Cool. 2.0, and then do a similar warning here, except for we'll say texture handle Atlas is not associated with a loaded font, and then we'll say Atlas, and we'll do Atlas. Cool. And return 0. So we have a return in all branches. Good. All right, so that's ready to go. I'm going to go ahead and take a quick break. When we get back, we'll get to calculating the UVs for looking at the texture UVs, and we'll get to calculating the quad coordinates that will be applied when you go to figure out where exactly to place the character. That should be fun. I'll be back in about 10 minutes, I think. Boop. Alrighty, I'm back. Let's pick up where we left off. So where we left off was we got the data that we need to generate font metrics, at least not generate font metrics, to reinterpret font metrics in a fashion that is useful to our game engine. We've got all that data stored now within the textures.cpp translation unit. It's being stored as a static maps up here. We got font kernings and font advances. And now we got to do calculations for the UVs and quads. And actually, now that I'm saying that now, I'm looking back up and realizing we haven't stored UVs or quads yet. We need to do that first. All right, let's do that. So while we're looping through all the glyphs and stuff, I'm just going to go ahead and get rid of this stuff now that well, actually, I need this code, don't I? I'm going to get rid of that and uncomment that and get rid of the outer loop. But basically, we need to get two sets of values out of. Really, don't want to go back for me. Oh, whatever. We need to get two sets of values out of the glyphs still. We need to get the atlas bounds, which is the essentially the pixel space UV coordinates, though it's expressed as in bounds, so you got left, bottom, right, and top. And we need to get the glyph dot get quad plane bounds, which is kind of a once removed way of getting the quad position relative to the origin of the baseline. So I think I got a good grasp of how that works going by a comment by the author clarifying it in the issues tab of the library. And basically we use these to determine the coordinates in it's kind of model space. It gets a little funky because when you're going to calculate the positions of all the vertices in the quad, in one sense you're doing it in model space, and in one sense you're doing it in world space, because the at the end of all of this, when you're working in the batch renderer, all of the quads will be in world space, pre-transformed on the CPU. But when you're doing each individual character's calculations, it's relative to a different origin than the regular origin. So it's like you're gonna calculate this all with regards to a moving origin, that the moving origin is the cursor for the place that you'll place the next character, and then you move the origin over on the x-axis by so many bounds, and then you transform all the quads again. And then that's actually putting it into world space. So this is there's two model spaces, I guess is what I'm saying. So quad plane bounds is the coordinates of the first model space, where it's relative to the origin, to the moved origin. So we're doing a model transform. We're working in doing a model transform from the 1x1 quad to that space, if that makes sense. So we get those values here. Now, so for getting the quad atlas bounds, basically we just need to divide the value by width, height, and so on. That'll give you the coordinates to look up. That's not going to change because your texture lookup coordinates is always going to be in the space of 0 to 1. You could do a pixel space UV, but that would require changing your shader to handle that, and that's I don't know. I think it makes sense to have for most games and most systems to have a normalized sampling from 0 to 1, and not have to do anything in the shader to make the sampling accurate. So basically, we just take the L, B, R, and T values. We divide them by the width and the height, respectively, because these values come back in pixel space. So pixel space referring to the actual pixel size, width, and height of the resulting atlas. And then we need to store the resulting UV coordinates in an array somewhere, or in a map somewhere. So what we'll do is we'll go to here. We'll do static std map graphics texture handle I said. There we go. And then within the texture handle, we need to associate the code point with the UVs. So std map again, associating the uint 32t with an std pair of glm vec2 glm vec2. The computer science-y person in me wants to just make every pair of vec2s just a single vec4, but for API readability reasons, I'm just gonna stand my ground and make this pairs of vec2s, so that when you look at it, you're realizing that you're getting two separate UV coordinates. Actually, hang on just a moment. I'm thinking back to when we go to actually use it in the draw text method, when we use that data. Now that I'm thinking about it, it might make more sense to do the left, bottom, right, and top instead of two corners. The reason why I'm saying that is because you're not constructing two UVs. You're constructing four, one for each corner. So it would make your code a little less readable if you had to deconstruct two different UVs to produce two more. So actually, let's rethink how we're doing the UVs. Instead of getting a pair of the coordinates, we could do, the way I see it, we can do a tuple of left, right, bottom, top, just as we get the bounds from the API itself. Or we could get pre-assembled vec2s, so one for each corner, ordered in the same order that you might order your quad. But you know what, now that I'm thinking about it, I think this should be just the floats, or just the doubles. Because while in my renderers, I'm standardizing lower left, lower right, top left as the order that you're doing the vertices in a quad, somebody writing their own 2D renderer might disagree, and so they would just want to know the left, bottom, right, and top bounds in normalized texture lookup space of the quad that they need to read. So yeah, I'm gonna do double. But I'm actually going to do it a little differently from that because that's a lot of things to have in tuple. So what we'll do is we'll do a static bool. The bool will tell us whether we were successful reading the UVs. Actually, no, that's useless. We'll just do void and we'll print an error message if there's an issue looking up the UVs. We'll do the atlas, we'll do the Unicode character, and then we'll need to do out floats. So float reference, or sorry, double reference. And I'm thinking I want to do doubles for the UVs in this case because because you're going at a much more granular lookup in the table and in the font atlas sometimes. Okay, we'll do floats. I don't think we'll actually practically need that extra resolution to get good looking text. So we'll do float by reference L R or L R B T. And then I suppose I should say out L. Is out a keyword in C++? No, it's not. So we'll do out L, out R, out B, out T. And then this API will allow you to do a little more clearly written code for getting the bounds for the UVs. This should probably be named get font car UV bounds or something like that. Given the limited number of times that somebody would ever have to call this API, I'm okay with slightly longer API names for these functions. Good, load font car UV bounds. And then we'll go back into the method here. Not there. Let's see for a second. Down. Where is it? Did I forget something? Source class may not be specified here. Oh, it's down here. It just took IntelliSense a little while to clear out all the other lines. Change this over to void graphics. Yeah, and then we'll do that, and I'll throw this on the next line to make it a little easier to read. So then we get the bounds, and now instead of storing the storing two vec3s or vec2s, I'll just store 4 floats. So this might be a little hard to parse at first glance, but I don't really care. This is all going to be internal anyway, and easy to see how it's used, or relatively easy, I should say. So that's the tuple, that's the map, that's the second map, and this will be font UV bounds. Cool, and then we can use this to store that data. Font advances, font kernings. Yeah. And then let's head back down to the loop where we're getting all the glyph information and backing it for later use. We will do, we got get quad, plane bounds, and atlas bounds. So we've here we've got the left, bottom, right, and top all set up. So what we'll need to do is we'll need to do font UV bounds at return val at the code point. So glyph.get code point. std tuple lrbt, because that's the ordering that I gave them before. Cool. And I'm doing lrbt, instead of going in a circle, we'll go x and then y. That's y. So x negative to positive, y negative to positive. That's just my thinking. And then that should be good for lookup later. Now we got to do the same thing for the quad plane bounds, which is going to be the way that we construct the actual quad coordinates in the first model space. So we've got left, bottom, right, top, because they do left, bottom, right, top. Yeah. Let's do you know what, it makes sense for me to continue with left, bottom, right, top for the for the quad chords as well, as opposed to doing pairs of vec2s, because for the same exact reason that you might order your points differently for UVs, you might order your geometry differently as well. So what we'll do here is we'll actually do the same thing. We'll do a static void instead of that. We'll do car quad bounds instead of chords. We'll do the same character lookup, previous character. I still want to make previous character an optional parameter. So I'll have to do the LRBT on in between Unicode character and the previous character. And that's getting a little lengthy. I like to keep this from going beyond 120 characters. That's the rule I've been using, but yeah, so I'll do formatting like so. Good. And then I need to set the signature in here to match. Void graphics. I'll get quad car bounds. Get car quad bounds. Get rid of that semicolon. All right, and then we need to do similar storage for it. So we'll duplicate this one as a reference, but this time instead of UV bounds, it's quad bounds, and that'll hold the geometry. Cool. So coming back to this is the example. This needs to be in reference of EM space. So as it is, the quad, so the UV bounds is always always given to us from the API in terms of pixels on the bitmap that we get for the texture. So that's always in that pixel space. That never changes. Because when we go to write text, we're going to do scaling based on the EM size. How many world space units do we want the EM size to be? It'll get a little bit tricky because what we have to do is we have to take the value that we get out, which I believe right now is in pixel space. Let me take a quick look at the kerning data we got out. All of these kerning values seem just a little bit too small to be handled in pixel space. Because we're talking about 0.0 everything almost for almost all these kerning values. So I'm actually not sure whether it's already in EM, in EMs or pixels. So I'm going to need to do a quick little bit of research on this one. We'll need to I guess I'll need to print this stuff to the console. For the sake of understanding the situation. So we'll do glyph, and we'll do L, R, B, and T. Yeah, L, R, B, T. And kind of just see what kinds of values I get from the Roboto font. That should give me a better idea of which space these values come back in. I suspect it's probably in texture pixel space, the same space in which the Atlas bounds come back, but I can't be sure. So let's see what we got. Can I compile this as is? Did I leave something out? I don't think I did. Yeah, so let's press F5 and see what we got on the console. I think after I've got text rendering working, I'm going to need to do a reconsideration of how I handle, what's this? Oh, I accidentally left the equals 0 on the definition for that method. I'm going to need to, before I start going all in on developing the enterprise editor, I'm going to need to restructure some things to prevent these freaking long build times from getting me down, because it's taking a while. All right, so here we go. We got all of the values outputted by the API. So it makes sense that Glyph32 doesn't give you anything, because it's just a space. You would only display nothing and move the cursor by the advance amount. So that's expected. But looking at these other values, they all tend to be, but they're all less than 1. All of the left and bottom values tend to be very close to 0, like plus or minus 0.0 whatever. And the bottom and top, or sorry, the right value and the top value tend to be quite a bit larger. The top value is almost always hanging around 0.75 for a lot of these glyphs. So I'm thinking that this must be an EM space, which kind of comes as a surprise. But a welcome one. Because I want to be able to work in EM space anyway. So I don't think I have to do any math here. I think I can just like pass these values straight to my my storage, so that I can just use these to construct quads in coordinates that are in reference to the EM height. Cool. So I think we're just going to go ahead and do that and hope for the best. Hopefully there's no more conversion that I have to do. My concern is that I'll go through all this work to get things set up, making assumptions about how the API is supposed to give me values, and then I find that a whole bunch of things don't work at once, and I have to fix every single one of them before I can see anything, which would make this kind of harder. So what we'll do then is we'll do font quad bounds at return val at glyph.get code point equals std tuple l rbt. And that should be good enough for our purposes. Cool, so that should be all the data we need. Let's start by the getter for font car UV bounds. Actually, these getters are pretty simple because I don't need to do any more conversions. I did all the conversions I need up here. So I can just pass along the data. So what I would do is I would do outl equals font UV bounds. Actually, it'd be std pair or std get at 0. Std get at 0 font UV bounds. Right? Did I use that right? Oh, if I have to do the lookup. At atlas at Unicode character. And that'll just get me the first in that tuple. And then just do this a few more times. We order it left, right, bottom, top. And we do 1, 2, 3. And then we it's a return void, so we don't need to do any returns. It's going to be a little more complicated on this one because we have to consider the previous character's advanced value, or the previous character's kerning value. So first let me get the basic outline stuff going. Quad, font quad bounds, so outl, outar, outb equals the bounds that we get from the character that we're looking up. And then we need to look up if the previous character and the current character have a kerning value. So if font kernings dot count and the lookup for this key is dictionary handle Alice. I keep forgetting for some reason that I have to look this up per loaded font. Count, and then we do the std pair of the Unicode char and prev char. We'll say if count is greater than 0. Then that means that we've got a kerning value to apply. And if we do, that's going to be applied to the left side. So out L plus equals font kernings atlas std pair whatever. Cool. And we don't need an else here because this is not error checking. This is just checking to see whether we have a pair, and it's a valid condition if there's not. Now I do need to wrap all of this in a map check anyway to generate warnings if you try to use an atlas that's not associated with a loaded font. So let me copy this warning. And do an if statement. If font quad bounds dot count atlas is greater than 0, which because it's only over 0 and 1, I literally just have to say this, but I don't know, for me it's a little more clear when I do it this way. Then we will continue with quad bounds with Unicode character. And I will actually want to perform a check on the Unicode character as well. We'll do that in a minute. Yeah, and then oops. And then I'll want to change the method name in the warning. Texture handle atlas is not associated with loaded font. All right. And then let's do a warning for if font quad bounds. Oh, this needs to be UV bounds. Right. Dot count, or sorry, add atlas. Dot count is for Unicode character is greater than 0. Then we will do the assignment. Else we'll do a warning. Font does not contain character. And we'll do Unicode character. Okay. Cool. And then what I might do is I might set these all to an erroneous value. But what I'm going to do is I'm just going to leave them at whatever initialized value was provided. By default, the value will be initialized to 0 in C++. So when somebody declares a float without initializing it, it'll be 0. If somebody's explicitly initializing it to another value before sending it to this method, and we have an error condition, then I don't know, they may want to use it as a error check of their own. I don't know. I don't see the value in setting the out value to another value in this case. I think I'll just generate the warning and be happy with it. We need to do a similar check for this guy though. And then do else quad font character quad bounds. Font does not contain character, blah, 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 blah. And then for previous character, we don't need to do a warning because previous character, you don't have to provide it. If you don't provide it, it's 0. And let me do a quick check on myself. Here. Yeah, 0 is a null value anyway. So if it's 0, then we can presume that that doesn't represent a character. That doesn't actually represent a character and won't be inside of a kerning value for any font. Like if you look through all this, there's no results. That gives me 0 up or down. So yeah, all right. So we're looking good. I just clicked live share. I don't know what that is, but I wanted to stop it. I accidentally didn't. Fuck. Sharing what? Visual Studio Live share file while access. I don't want to do that. Cancel. I didn't mean to click the share button. I don't even know what that does. Presumably it's a team working feature, but geez, one click and then it starts to put me online. All right, good. So we've got everything I think we need. Cool. So I think that's that. I think that's all we need to do from the graphics API side. I think we got all of the data that we need to make a text renderer. So I guess let's try our hand at one. So this is going to be the exciting part, actually getting this to work. So for starters, the text origin and orientation puts us at a point in world space, and gives us the room in which we will be writing text. EM height will give us the scale of each line based on world space. And then I can't believe I almost forgot this part. We need a string to write. So std string text. And I might as well put that on the same line. So let's head to render.h and change that signature up a little bit. Yeah, I think that's probably what we need. I think that's probably everything. For now, I'm just going to do a regular std string, but in a real renderer, I will want to have like a stdw string to be able to handle wide character strings. So that way you can load text from a wide text file and include, non-American or non-Western characters. Cool. So, all right, after all that work, I'm a little overwhelmed. But let's see what we got. We have the origin, the orientation, the EM height, and the text. The first thing I'm gonna do is I'm going to move the font loading into the initialization call for the renderer system. So let's go to the dev state. So this is the place where I've been working so far. I'm just going to get rid of all of that. And I don't need any of this either. So I had all this code specifically written for the purpose of rendering directly from here. And I don't need it now. Yeah. And we'll comment out anything that I broke. I don't need the toggle action here. I might want to set up the system to handle input for the purposes of testing, but that'll be on the other side of this. I will do. Let's see. We'll go back to allowing the scene manager to draw the scene. Actually, no, we won't. Instead of, I'm not going to tell the scene to draw the sprites that are loaded from the scene file. I just want it to be the text that we render now. Good. Yeah, let's make sure this compiles before we're moving on onto the main show. Okay, compiles. We don't have anything displaying because I got rid of all the rendering code from the state side, and we're going to move that into this side. So first, let's take a look at the init call down here. And then I will. Normally, I wouldn't do it this way. But I will, in this circumstance, I will just have the 2D renderer automatically load up the Roboto font, load font file, and we'll do content folder Roboto regular.ttf. We'll store that handle. So I'll do static graphics texture handle. Let's do font at this, and we'll assign that here. So after we've set up the vertex array handle stuff for doing batch quad rendering, we just load the texture for the font. Load font file now also loads all the metrics we need for rendering. So that should be it. We should just be able to start using the font atlas handle and draw text. So let's think a little bit about how we do the transform in this case. What I think I want to do is I think I want to do all of this in model space first. So imagining model space here being that the origin is at the center of the universe right now, and the text as it goes off to the right is being written from that origin. And then we would transform all of those points at once. That doesn't sound like a good idea now I'm saying it out loud. Instead of doing that, instead of doing a transformation on the points after I have created them, I'm just going to do the transformation right away. So that means we need to keep track of the cursor position. In this case, it's just going to be one-dimensional, so we'll just do float cursor pause. This will be the x-coordinate in the space that we're writing the text. And then we will multiply that against a vector representing the orientation. So orientation is going to be a little different in this respect. So an orientation of no rotation means that it's just going to be viewed straight on X, Y axis aligned to the unit space. So what we need to do is we would need to rotate a vector pointing straight by the orientation. For reference, I'm going to confirm how we did it in the camera controller. Move back, right back, up back. Camera up. So with for a given camera rotation, I can literally just multiply the z by the quaternion, and then GLM will do the transformation, and then presumably do the reverse quaternion multiplication to produce the correct value. Because when you're doing a transform on a vector by a quaternion, it's not as simple as just doing right to left multiplication. You have to do pre-multiply with the quaternion, and then post-multiply with the inverted quaternion or something. But apparently this is something that GLM takes care of for us. So yeah, cool. So cursor position, we'll start that at 0. And then we need to do, GLM vec3 right here. And that's going to be equal to orientation times a vector pointing in the z direction. Right? No, wrong. We need that to be in the positive x direction. So we've got this vector, we are rotating it to match the orientation of the quaternion that's provided. Right, okay. And so basically when we go to produce the point, we would multiply right direction times cursor position. And that'll give us the point in 3D space that represents that origin. Yeah, and we would do that multiplication against the other points representing the quad. All right, cool. We're getting somewhere. Taking a quick look at the sprite rendering code, because I'm gonna piggyback off of the work that it does. Query sprites, delete sprite, draw text, scene draw. So what we do in the case of scene draw is we assemble outverts, which is a globally declared array of vertices containing the points that we need. So what we'll do is we'll just go through and assemble those for each character, and then push them out to the graphics card using set vertex data and then draw triangles at the very end of it. So yeah, so I guess what we'll do is we'll start with a for loop. We'll go for const car by reference in C and text. So for every single character, we are going to perform this operation. We will need to go to graphics. So we'll need to set the UV bounds and the quad bounds. So we'll need a tracker for how far we are in the array. So size t I equals 0. This will be the index into the vertex data. So we'll do outverts at I, and then we've got the position, texture, and the UV. So in this case, the UV, we're going to need to assemble it, equals graphics actually, instead of doing I, let's do quad number. The reason why is because we're going to do this per quad, do this loop per quad instead of per vertex, because we're going to do 4 vertices at once per loop. So anyway, quad number, the NUV equals graphics get. Actually, I'm going to need to do this a slightly different way. So right now, graphics get UV font character UV bounds. It'll take the atlas. So in this case, we got font atlas. It'll take the character, which in this case is, ooh, I guess it is C, because it's in ASCII format. And then we need to provide the address of the values to change. So I think this is where I'm going to get a little tricksy. And I'm going to provide it the address of each of the points that we need to assign it to. The only place where that breaks down is that we need to assign it to more than one value. So I'll go ahead and do the float L, R, B, and T, and we can just do L, R, B, and T. Cool. And now we've got the left, right, and bottom for the UVs. So we'll assign those first. So the first is going to be on the lower left-hand corner. The X is going to be L. And then we need to do Y for each of these as well. Y is going to be bottom. And then do this for a couple more. Quad number, oops, plus, in this case, plus 1. That's going to be X is going to be R this time, Y is still going to be bottom, and then for plus 2, we're going to do R for X and T for Y, because now we're on the upper right corner of the quad. And for the last vertex, the X is going back to the left side, and the Y is still on the top. Okay, so that's the UVs assigned for each vertex in the quad. And we will now get graphics get font car quad bounds, passing in the font atlas, the Unicode character, so C, then L, R, bottom, top. And then in this case, we need to specify the previous character. So we'll need to keep track of that as well. So we'll do car, prev car equals, first we'll do 0. We'll do a null value. And then we will pass it into here by value. Cool. Now this will automatically handle the kerning for us. So we need to, at this point, just do assignment of the position. This is going to be a little trickier because we have to do the transformations now. So we have to do the matrix multiplication. X, Y, X, Y. So instead of in UV, we've got in EP pos. I don't think I renamed the vertex in this API yet. So I'll double check that real quick. No, I did. I renamed it to EV position to reflect the new normal I want. EP position will be a globally available vertex attribute in all shaders for enterprise. Cool. So we've got the quad number equals quad number EP position.x.y equals LB RB RT LT. That is totally fine if we aren't transforming this in any way. So in other words, it's not fine. We need to take these LB and RT values, and we need to associate them with the correct place in world space. So let me think about that. I'll need to do, so right direction is currently X positive, given the orientation provided by the developer. Now I need to do an up direction. Because I need to take the LB RT values. I need to move them over by cursor pos times right direction. So I need to make a transform matrix that does that. But then I also need to do a transform that will go from that point to, that'll go from that point to the positive or negative bounds of the quad. Which means that I'll need to do the positive Y transformation first, and then do the multiplication by the matrix to get it in the right place in the right direction. Which, you know what, actually might make this easier, because I can just do that linearly. Oh, wait a minute. I don't think I have to do that. I don't think I have to do that at all. So if I just make my translation matrix translate the point along the right direction, then it'll just preserve the Y coordinate from the get font car quad bounds. So yeah, actually, I only need to do a matrix for translating the points with right dir times cursor pos. Okay, so that means for every character, we will take cursor pause times right dir. That will be the movement vector. And then we will do glm translate glm mat4 1.0 to get the identity matrix, and we will translate by this. And that will return us the translation mat. So glm transmat. Right? glm mat for transmat. All right. Yeah, okay, that works. So this we can multiply by the each one of these vectors to put it in the correct place in three-dimensional space. I do need it to be a three-dimensional transform because otherwise I would have to go through all of these and multiply again to put them in 3D space. I can't just put it in 2D space and then loop through, and I don't know. I could do it either way, but I'm pretty sure it'll be faster just for me to do this while I'm iterating through the first time. So what we'll do then, I might be able to just do something like this, LB. Or I would need to actually say glmvec2. I'm going to simplify this a little bit. For our purposes. Yeah, that works. I will do assignment one vertex per line. Okay, and do the same thing here. Oh, because this is a vec3 and it needs a z position. Yeah, so I'll do that. And this. So, and this. All right. Cool. So now we've got, just clean this up a little bit. So we've got 2D vectors to multiply here and 3D vectors to multiply here. So in the case of UVs, UVs I don't need to multiply. I only need to multiply these. And these are already 3D vectors, so that works for me. All right, so what I can do, oh, perfect. I can do that right here. I'm just realizing the cleanest way I can write this to directly do the multiplication in one line. I can do a vec4 with these values, and I'm putting the 1 on the end to make this a 4D vector, which is necessary for multiplying against a mat for. Oops, that's not right. Okay. And then I can just take and multiply them against transmat. And then I have to cast the whole thing back to a vec4 because that's how GLM does it. GLM vec3 like so. Right? Oh, but I need to do GLM vec4. Cool. Right, so that's looking better already. Whoops. Accidentally hit Control B. I just did it again. Gosh, stop it. All right, I don't know what's up with me. Control V is what I wanted. And then I need to do these and that. Cool. So let's review the math, make sure I'm not screwing something up. So the cursor position represents the the amount of space we have moved from the left side to the right side in EM space. The right direction is going to be the vector pointing towards the right, oriented as the provided orientation has been provided. We loop through all of the characters in the string. We create a translation matrix for each place in the string by taking the vector, the right direction vector, which is normalized, times the cursor position to get the position in model space, and then take, well, in model space relative to the origin of the text. And then we translate everything over by oh, hang on a minute. Is that right? Yeah, that is right, because I'm moving the text over there. Cool, so we got transmat. We take the UV bounds for the character that we're looking up at C. We are assembling its UVs and for quad plus 1, 2, 3 to get the going in a circle. We are getting the quad bounds for the actual geometry, considering the kerning of the previous character. We are then taking and multiplying the position provided by the quad bounds by the translation to put it in, to move it over along that line, and assigning the position to it. Cool. Okay, so that seems to be the UVs and the position set. So there's a couple of things left to do. Before I forget, I need to do I ++ here, or quad number ++ here, and I need to do there was another one that I'm forgetting. Previous character equals C. Yeah. Cool. And then we need to take care of the texture assignment now. So given that this is a batch renderer, the way that I was doing it before is that I would assign a texture to a slot if and then use it if it's not already been assigned to a slot. But in this case, I'm just doing a straight render of text. I'm not actually engaging multiple fonts at once. So I don't need to fuss with that. I just need to do outverts at, actually I need to do graphics, bind texture, and just bind the font atlas. And we'll do it to, what is the array? Font atlas. Outverts, .intex, j. btext textures is what I named the, array of samplers in batch shaders. So we got hash name. What did I just do? Team Explorer. Dang it. btext textures. And then the index. Because this is an array, I will specify 0 is the index. And the only reason why we're doing it this way is because I want to engage the correct shader for it. So we need to say enable shader option, batch shaders, setting the model matrix to match the or to be at the identity matrix. Cool. And then down at the end we have to say set vertex data, draw triangles, and yeah. In this case, it would be quad number. Times 4, quad number times 6. Good. All right, and then for all of these, I need to do out verts at quad number plus 1, 2, and 3. Dot in text needs to be equal to 0. Because that's the slot that we are using, we are only doing one texture at a time right now. And then I'll set this for the others as well. Plus 1. Plus 2 and plus 3. All right. I think that's it. I think that's all we need. We're populating outverts with all of the stuff that we need. The first index of the first vertex to replace. We're always starting with the first in this case. Yeah, I think that's it. So that should, fingers crossed, draw us a properly formatted line of text given a string. So, moment of truth time. We're going to go into the state. We've got the renderer 2D is handling the loading of the font and all of that stuff already. We just need to, in this system, after we've pushed the camera from where we're going to do the first-person camera movement, we're going to do renderer 2D, which we haven't loaded it yet. Let's do that. Include enterprise graphics, enterprise systems, renderer 2D.h. And then from here we can do renderer 2D. No, can't we? Do I have to? Oh, it's in the enterprise namespace, and I'm not in that. Okay. And then down here we would do renderer 2D colon draw text. It's got a W at the end. I wasn't expecting that. Let's go back to the header. Did I accidentally No, it's dropped. Oh, god damn it. There's a macro in the Windows API called draw text, and it replaces the instances of draw text with draw text W or draw text A, depending on whether you're building on Unicode or not. So do I really have to give this another name? I'm going to say if def draw text, def draw text. That's a pretty, yeah, I don't know. That might not be the best way to handle it, but I am now going to do this because the headers included it. It's corrected the macro here. So the origin in this case will just leave at vec3 0. The orientation we'll leave as looking dead on, which I believe is 100. And then EM height, I'm going to leave it at 1. And then the text, hello world, maybe the most exciting time I've ever written, hello world. And let's see what happens. Just wrote a whole lot of code, and I don't know at what point it might break. Okay, I've got an exception. Sampler uniform does not exist. What's the sampler uniform? Let's go back to the EP null shader. I didn't bind a texture. Of course I didn't. So let's take a look at the shader. We've got font renderer test. So font renderer test presently is just a one and done shader. I'm going to update it to do batch rendering. By using the helper methods from my library. Batch textures.glsl. Now, when we do uniform sampler 2D text, instead of doing that, we would do btex sampler 2D and declare it with the macro. In here, we would say btex pass the text to the fragment shader, and then the fragment shader we can use btext text texture in order to look up the stuff. So in this case, instead of doing texture text uv.rgb, we should be able to just do btext texture text uv. And I hope that the fact that we're just calling .rgb after it is not a problem. I don't really remember how let me open up the header and make sure it works the way I think it does. Yeah, we're done with the vendor folder right now. Define. So it should do a macro replace. But you know, I think what would make me feel a little bit better would be if this was actually a function. So let's do a function that returns a vec4. And then in its body, we will do, we will pass the stuff through. And then when we do it in the vertex shader, we will do it, or not the vertex shader, in the batch textures version, we will do vec for like so, and do it like that. Now the trick is that we will need to provide types for these attributes now. So text ID takes, in this case, an int. The integer ID of the texture in the array, and then this is a vec2. Okay, and then here we are doing a sampler 2D, and we're doing a vec2 here. Cool, that should work better. Cool, and now in here, hopefully that'll make this batch compatible. While I'm pretty confident in the batch textures GLSL implementation that I've got so far for making things work either in batch or not in batch, it's also kind of not very tried yet. We haven't used it very much, so we'll see how this works. Coming back to render 2D. I'll want to bind the shader for use here. So let's go back to this guy up here. We'll do load shader file. Okay, so load shader file has been performed on font render test.glsl. We just need to bind it. So right before draw text, we'll do graphics bind shader, and we'll provide the name of the shader, which is what was it again? Font render test. All right, moment of truth time. See how this goes. Okay, we've got a problem again. What's that? Exception was thrown. Let's take a look at the console. Fragment shader compilation failure. Unrecognized pragma option. Function B. I forgot to put a return val in my texture. Whoopsie. Stop. It's always some little thing. Coming back to my compiler. Actually, out of curiosity, I want to confirm that if I hit continue, that I just see magenta. Continue. Huh. Okay, well I do see magenta showing up in the preview, so I guess that's good enough for me. But yeah, let's head back to the shader. The header, that is. And in the header, what I forgot to do was return the value. And what now? Let's take a look at the console. Fragment shader compilation failure, unrecognized, undefined variable in text out, in undefined variable text. So I'm misusing my header again. Part of the problem is that the future use of this shader header is intended to be used in conjunction with a materials system, and I don't have one. So I'm having to fake it. So when you declare a sampler with the macro btext sampler 2D, I'm actually cheating a little bit. in that it will give you it'll give you a fixed name for your texture. Whereas in the future version, it will be using the the macro concatenation symbol to generate a unique name for each of the textures that you want to use. So let's review the pre-processed source here. So fragment shader, if def vertex position. All right, so batch shaders.glsl. We've got batched textures. So we got btext sampler 2D name, int in text, flat out int in text out. And then in define btext sampler 2D. Let me stop this for a moment, and I'm just going to open it up in Visual Studio Code. Going to the data folder, the GSL dump test renderer, or oh, it didn't dump it. Interesting. All right, let me hop back into the shader code. For starters, let's track the changes I made. So I made changes to btext texture. Okay, in this case, the mistake that I made is that I didn't actually change the name of the input to the method, and I should have. So now it's a method call where I have to provide the name of the thing that we're dealing with. Okay, and I'm seeing now why this is a problem. I can't undo this as a macro because I need to know the name, which is defined in macro space, to substitute it into the texture thing right here. So yeah, I'll just undo all those changes and hopefully it'll work. If it doesn't, then I'll have to restructure the code a little bit to make it work. Okay, still got a problem. Man. I was really hoping it would work on the first try. Unrecognized implicit cast from vec4 to vec3. Syntax error, unexpected dot at token. Okay, implicit cast from vec4 to vec3. That would probably be here when I use btext texture. Yeah, so that's not quite going to work. Btext texture now is a macro that replaces the section with the btext texture lookup. So what I need to do is I need to actually wrap this a little bit. And hopefully that'll be enough, because I don't want to do too much more work on the shader right now. Unexpected semicolon. In my redefinition of btext texture, I accidentally put a semicolon at the end, so it doesn't exactly substitute. I need to, yeah, fuck. Seems like I'm always missing things like that. There shouldn't be a semicolon at the end of any of these macros, actually, because I'm always following them up with semicolons when I use them. Just a bad habit, I guess. Okay, cool. And then stop and compile. All right, what now? Undefined variable text. And this is in the fragment shader. Oh, because I'm using texture size on the text. Okay, yeah, that's supposed to get replaced with a macro. Man, okay. Head back to the shader. I suppose this is all making the batch textures macros more powerful. So the problem is that text is either it's a macro symbol that's either going to be redefined as an integer or as a sampler 2D, depending on whether I'm batching the texture or not. But I was trying to use it in texture size. So this gets replaced with two declarations, technically. Or no, not two declarations. It just refers to a texture ID that doesn't. It refers to text, which in the finished version, when I have the material system built into this, I can actually just use the name as the texture. Or no, actually I can't. Because this will either be an integer index, a named integer index, or a sampler 2D name. One way I could do this would be to provide a macro version of texture size to use instead. But I feel like that's starting to go down a rabbit hole, or starting to open a can of worms, because if that's how I'm going to approach this category of problem, then that means that I'm going to have to provide a whole bunch of standard function overloads. So I might have to rethink how I do the batch texture header, but for the moment, what I'm going to do is I'm just going to go ahead and do a redefine of the texture. So what I'll do is I'll do btext texture size. Fine. Well, I'll do it as a function. No, I have to do it as a macro, right? Fine. Btext texture size. Taking in the texture and the mid-level, and define it as texture size, and then I'll do text textures, text, yes, and then MIP level. I'm pretty sure that's correct. So text, what we'll be passing in is text. Okay. So whatever we pass in is going to be the integer. But instead of doing it correctly, I actually do have to cheat a little bit and use this as fixed name because we don't have materials figured out yet. And then we set, yeah, okay. And then in the fragment shader for the non-batch version, define btext text MIP level. It's going to be texture size text MIP level. That should be it. And then in here, we're using, instead of texture size, we're using btext texture size. And boy, oh boy, it feels like kind of a hacky solution, but it's not the problem I want to be working on right now. Okay, so we've got a compilation figured out. So now we've got the font loaded and something that decidedly does not look like Hello World. So it looks like we've got almost everything wrong, huh? So for starters, it's looking like these quads are being transformed incorrectly. Let me change over to my gamepad to try and get a closer look without breaking everything. It kind of seems like the transform is getting away from me. So looking at this, we've got like a chain of smaller and smaller triangles, it looks like. And then the UV coordinates for the triangles are also incorrect. So let's head back to the renderer 2D and let's review how we generated these. So I'm going to go ahead and set a breakpoint here, and we will step through the calculation of the first letter. So for comparison, so yeah, the first letter is an H, part of the string hello world. We are translating the cursor position times right direction. Oh, we're not incrementing the cursor position. Whoopsie. All right, let me do that. Cursor pause plus equals graphics get font character advance. We're doing the atlas font atlas, and the character in this case is C. So that'll help with spacing the letters, I believe, but it won't help with the transformation part. I don't think. Let's see what this gets us. Okay, so it's going in the right direction, so to speak, but the we've still got some weird skewing going on, and this is telling me that I think every single character that we're drawing here shares the origin point, and they might all be approaching the same edge over here. That's a little weird. But I don't see any Z fighting on the text at top. There might be some down here where all the letters are squished together. Yes, there is. So they're kind of all overlapping, bundled at the bottom there. So let's go back to what we were doing in inspect. Okay. So we get the LR and V values. L is 0.13, 0.220, 0.3, 0.43. That seems okay for the range of UV values. I'm gonna forget about UV values for a second, because even if those are totally incorrect, we should have the correct locations and sizes of the glyphs, which is handled down here. So let's take a look at these values. We got L is 0.05. We got 0.64 for the R value, negative 0.029 for the bottom, 0.74 for the top. That actually seems reasonable. So where did we go wrong? So the position for the lower left-hand corner, 1, because this goes in clockwise, starting from the lower left corner. We are taking the vector with the left edge and bottom edge for the X and the Y. That's correct. That will give us the point with relation to the origin in 2D space. We're giving it a 0 depth, and we were giving it a 1 so that it'll multiply against a flow 4. X, so the right direction is correct. It is 1, 0, 0. 1, 0, 0. So the translation matrix is presumably correct as well. One, 1, 1, 0, 0, 0, 0, 0, 0. So this is the first column, 1, 1, 1. Yeah, that should be correct. Okay. And then we translate it back into a vec3. And that seems to be a valid way to do this. Taking a look at the way that we did it for the regular quad renderer. We do the model matrix, where we take the position where we want it to be in world space. We multiply it by, or we translate it. We provide it as a second parameter for GLM translate against a identity matrix. And we're not doing rotation and scale right now. Even though technically we should be, because we're not doing. Or actually, never mind. The orientation is kind of baked into the right direction, so we're stepping over that. Okay. Hang on. I see what we did, I think. So, stop. So quad number gives us the quad that we are working on, but it does not it does not index the correct location in the array. It only increments once per quad. It needs to increment 4 times per quad. Otherwise, we're just overriding the vertices second, third, and fourth positions for every quad as we loop through this. So, yeah, okay. Let's see what happens now. Oh my god! Haha! Look at that! Look at that! Oh, that's beautiful. It is working. That is cool. This is the first time I've ever done anything like this, so that's pretty dope. So now we've got text working where we generate the atlas, we get the matrix from it, and then we take a string and compose the sentence from it. Wow, that's cool. Let's try another font. Stop. Go to the renderer 2D init function. And instead of doing C Roboto regular, let's go to fonts and pick a cool font. Let's try Cooper. So that's underneath fonts, Coop BL. Oh, this is dope. Haha! Nice. As they say, it is lit, fam. Okay, we got a, this has revealed a small problem. So as I move the camera around, we've got Z fighting on the edge of this glyph. And the reason for that is I have depth testing enabled. And these are on the same plane. So the kerning looks correct. All of the letters appear to be correct. Do they, though? Hang on a second. Does that look correct? Like if we can see the edge. Doesn't that space between the W and the O seem a little big to you? Let me check this one. What was the font we had used? Cooper Black. I don't know, I guess that's just how the font is. Yeah, I thought maybe that was a sign that there was something wrong with the kerning values that I was using, but no, it's actually just a little bit wide on the W. Okay, that's good. But yeah, so basically if I disable depth testing, then this should theoretically work. Actually, no, it wouldn't, would it? No, it would. I think. I'm on the fence. I'm still kind of new to this world. So heading back to the scene manager, I currently just have blend mode set to translucent and depth test set to true for the whole scene. Turning off depth test. does not appear that there's any conflicts. Because what's happening here is that one character gets drawn on top of the other. And it sort of just composites the next quad on top of the previous one. Because they're all visible. GLSL will actually do the blending per fragment, and it'll do both fragments. Another way I could handle this would be if I wanted to leave depth testing enabled, I could go into the shader and do a discard. So in the main, I would have to do the opacity calculations, but I would do if opacity is less than 0.5. Then I would just say discard, I believe is the keyword. And then what'll happen is that the fragments outside of the scope of the the character won't even get drawn. In which case, even though now I've got depth testing enabled, depth test is true, we don't see that Z fighting anymore. Okay, cool. I'm really mighty pleased that I got this working today. How long did that take? 4.5 hours for the first time I've ever done this, so that's not bad. And what did the character glyph come out to be? Yeah, so this is from the entire character atlas is 256 by 256. Yet we're getting this fidelity of the letters. That is cool. I am mighty pleased with myself. And what I'm most happy about is that once we sorted out the basics, like the things that I overlooked about like rendering the quads and whatever, that the metrics actually worked exactly as prescribed. So these should be in size 1 world units. So if I was to take and set the origin to be, let me find the spot in the code where we did the drawing. Draw text. I'm going to duplicate this line, and we'll do a new position at 0, 1, 0. So it'll be at the 1 y coordinate. I should expect to see those stacked neatly on top of each other. Oh, no, they are not stacked neatly on top of each other. Why would that be? Oh, because in the draw text method, I'm not actually using the origin right now. So, so we got the right direction. I need to add the origin to the right direction. Wait, no, I don't. I need to do right direction times cursor pause is good. That's good. Whenever we do the position, I need to be adding the origin to it. So let's do that real quick. Oops. Like so. And that should place the text relative to the origin I provided. There we go. So with the text being positioned at 1 world unit above, we see that these neatly stack within each other. That's because these are being scaled at 1 EM. So an EM is the pixel space. so the number of quote unquote pixels in a texture that fit within a line. We're kind of flipping that scale thing around. So by default, the height of the space that you write your text in, the EM height, is going to be 1 world unit. And this I think this arrangement will work quite well in the way that it'll work quite well in the fact that when you want to work in pixel space, you can just set your camera transform to be that, and then do your EM height in pixel size. So it'll be a 1-to-1 correspondence once it transforms on the GPU. But yeah, we've got some crisp, clean text from pretty low resolution textures using MSDF fields, using any font we want. I am mighty pleased. I'm gonna play around for just a little bit more. Like, let's pick another font. See how wacky we can get. What's this? Abrima. That's an interesting font. Abrima.ttf. Let's try that. That's in Render 2D right now. I wonder what Abrima is supposed to be. Oh, that's interesting. Oh, that's weird. So it just, did I hit the wrong one? I guess not. I guess you have to use the, so I guess this is just for writing in another language. So when I use English characters in it, it just does that. All right, yeah, so let me try another English-based font. This one, they Consolas, that's a good one. So Consola.ttf. Nice, and it's looking with the correct kerning and everything. Fonts like this one, I think, will play very nicely with the MSDF rendering at low resolutions. I should hang on a second. I should go back to allowing the toggle to toggle the shader that I'm using, because now I can, when I was commenting out the code for the renderer from the development state, I commented out and removed the code for toggling which shader we're using. Here, so underneath where we got bind shader, we'll do if is MSDF, or MSDF, render MSDF is what I made the rule. If render MSDF, then we'll do test render, I think it's test renderer 2D. Test renderer 2D. Else we'll do that. And I've got a tab key bound to change the both of these are compatible with the batch shading model. So now I can press tab and switch between which one I'm looking at. Oh man, that's cool. Maybe I'd find it less cool if I didn't just spend for freaking ever figuring this out. But yeah, I think it's like, what am I at? I'm at like 8.5 hours or 9 hours of work. Never having done text before, and having the ability to type any text with correct kerning and everything from an MSDF library, while having to kind of figure out the API by myself because there's no documentation for it. Yeah, I'm pretty proud of myself. I'm gonna go ahead and end the stream. I'm just kind of playing around now. Hope this video becomes useful to somebody in the future, though maybe I'll do a tutorial on the MSDF library that's not 4.5 hours long. All right, have a good night, everybody.